Alright, let me set the context for the video. In this video, we're building an execution platform like N8N from scratch in the MERN stack. Specifically, the video is divided into 5 parts. Firstly, we'll be going through the architecture of the video. Step 2 is going to be writing the front end, mildly complicated front end for building a graph that is required in a project like N8N. Then we'll spend some time writing the backend, the schema, the database. Then we'll spend some time syncing the front end and the backend, which is a little challenging here. And lastly, we'll write an executor that actually executes the workflow that the user created. Specifically, the kind of workflows that you can create using this application are going to be trading workflows. So you can, for example, create a workflow that lets you buy Solana every 5 hours. It'll be a graph that looks something like this, where an order will be placed every 5 minutes or every 10 minutes to buy a specific asset on an exchange. You can buy various assets, you can buy them across various exchanges. That's the kind of workflows that you can create on a platform like this. Also, thanks to MongoDB for inviting me to explore their platform and making this video possible. With that, let's get into the video. We're building a no-code platform very close to N8N. N8N is a workflow platform that is very popular right now. OpenAI released something similar. N8N raised around $285 million in the recent round. N8N is also open source, and it's a fairly hard thing to build. We'll be building N8N from scratch for a specific use case, even though you can expand this logic into any use case that you want. Currently, N8N has a bunch of nodes that you can create. Commonly used ones are send an email, send a Telegram message, listen to a WhatsApp message, things like these. We're going to focus on a very specific use case of trading agents. How can you create a no-code platform where people can come and create trading bots or trading agents that can place real trades on their exchanges like Zerodha, Binance, things like these. The goal is that by the end of the video, we understand how a platform like N8N is built. What are the challenges that come on the front end when you try to build a graphing chart of sorts? How do you store that on the backend, and does it make sense to use an SQL database or a NoSQL database? Surprise, surprise. In this specific case, it makes a lot of sense to use a more flexible database when it comes to schema, something like MongoDB. So we'll be using MongoDB as our primary data store. And by the end of the video, you'll be able to understand how can you ingest trading data, how can you build tools on top of that trading data and allow traders to create no-code trading strategies using workflows very close to the workflows that you see on N8N. Without any further ado, let's get into the video. All right, let's get into the overview of the video. The video is going to be divided into 4 parts at a high level. We'll first understand what exactly we're building. What does the final UI look like? What would the backend look like? What is the functional requirements for a product like this? Then we'll understand the architecture, basically try to write down all the services, the front ends, the backends, the other microservices, the database, the schema, maybe at a very high level. How would the application look like if I was answering a question in a system design interview? How would you create something like this? Then we would move on to writing the front end first, which is generally something you don't do. You usually write the back end first and front end comes in the end. But specifically for this use case, the front end will dictate a lot how our schema looks like, because the front end is going to be a very complicated graph, something similar to this. As you can see, this is like a DAG, a directed acyclic graph, or a one-sided graph of sorts. It makes more sense to first build this on the front end and then figure out how do you store this graph on the back end before we write any other logic of actual trading execution and the final business logic that we have to write. Before writing the business logic, we have to write the graph on the front end and somehow persist it on a back end. That's what we'll spend our time on step 2. After that is done is when we'll start to write the backend routes. Very fairly simple authentication, probably email, password, magic links, something like that. Then we'll write the backend logic for creating a workflow. A workflow is basically something like this, a place where traders can come and create various types of nodes. For example, this specific trader might create a workflow that looks something like this. Whenever the price of Solana goes below $150, that means if it goes from 155 to 153 to 151, whenever it hits 150 or basically crosses that chasm of going from 150 to 149, is when they might want to place an order like this. A long 10x Solana on lighter.xyz, which is one exchange, a short 2x Solana on backpack.exchange, a short 2x on Hyperliquid. Kirat, why would they want to short on one place, long on another place? There are many reasons to do that. Really depends on the trader and their logic. Why would they want to long on one place and short on another place? We are supposed to support every use case that they want. And one such use case can be that whenever the price goes below a certain point, the simplest use case is this: let them execute whatever trades they want. Another good use case can be whenever they can put triggers on top of some financial indicators. What these financial indicators are, we'll try to understand. Maybe we'll not even build this. When we build the simplest version, we'll just build a simple price trigger. But one thing that they might want is whenever the RSI, which is a financial indicator that you can calculate based on the price of Solana over time or price of a specific asset over time, whenever it reaches a certain point is when they might want to long, short, or do something else. Or another common one can be every 10 minutes, they might want to just long on a specific exchange. They might just want to DCA or daily cost average on a specific exchange or multiple exchanges. Just to make sure, they get the best price, or they just want to buy Solana once every year. So, this workflow sort of lets them do that. These are the kind of nodes that we are supporting. N8N supports slightly less trading specific nodes. The general place you might want to use N8N would be, to create AI nodes, to create email workflows, to create sales pipelines. This is not that. That already exists. N8N has done it fairly well. The two approaches we could take in this video was building nodes on top of N8N or building N8N from scratch. I think there's more to learn if you're trying to build N8N from scratch. That's also one of the projects in Super 30, which is why I wanted to give a brief overview of how that is built. After we're able to create these nodes, sync them from the front end to the back end is when we'll start to create another thing called credentials. Basically, whenever a user might want to long on Hyperliquid or Backpack or Binance, they need to provide us some sort of credentials. Usually these are API keys, but in case of more complicated places like Backpack, there can be private keys, public keys, things like these. So it's not necessary that every exchange would just have an API key that's enough to trade on it. They might have something else. The schema would look very different for every external service over there. The schema of what you need from the user on Lighter would be very different from the schema of what you might need from a user from Backpack. If we eventually support things like sending out emails, okay, whenever this trade is made, I also want to email the user the specific trade has been made or something like that, or what price the trade was made on, so on and so forth. We can also add an email action over here or an email node over here, in which case we would need some sort of SMTP credentials from the user. So it's not just the graph that we have to store. We'll have another very important page over here, which will be the credentials page, where the user will share their credentials with us. Now, this could be the credentials of an exchange. This could be email credentials or SMTP credentials. These could be WhatsApp credentials. It really depends on the user and the kind of nodes that we support. And lastly, we have to create a separate microservice called the executor or the price aggregator. We'll come to what this is when we reach the architecture section at a high level. This is what we have to functionally create for the end user. The end user can come to the website, put a bunch of their credentials for their exchanges, for their email, and start to create workflows like these. A workflow is nothing but a trigger and a bunch of actions connected through a graph. A trigger is what triggers this specific workflow. For example, in this case, the trigger is if Solana goes below $150. In this case, the trigger is every 10 minutes, we want this specific workflow to run. Whenever this trigger is triggered is when whatever graph is created after that needs to execute. In this case, all three of these will execute parallelly. In this case, all three of these will execute parallelly. And as soon as this is done, the next one is to execute sequentially. So only after the long has been created on Lighter do we want the email to be sent. The things that we want to support right now for a V0 would be triggers that will be supported would be on an interval. So every 5 minutes, every 10 minutes, or on price flip, the user can select if the price goes above a certain price, they want to buy or sell. If the price goes below a certain price, they want to buy and sell. For actions, we can support many things. One thing we want to support today probably is going to be, I'll add another thing here, which is going to be sending email / a telegram message. So we have, non-trading nodes that we support as well. And then allowing the user to buy or sell a specific stock based on a specific price, or long a short or short a specific asset. Basically take slightly more leverage on a specific asset and buy it on a perp rather than buying it on a spot market. That's the high level of what we're building functionally. Functionally, the user expects to be able to create such workflows, and they expect the workflows to just run. If the price does go below 150, they do expect all of these to trigger every 5 minutes. If they've created this workflow, and if this is a production workflow that they've enabled, they expect to go long on these three markets every 10 minutes. That's what we require functionally. Next up, let's get into the architecture of what we're doing today. All right, let's get into the architecture of building something like this. Fairly simple architecture. We have the standard CRUD, frontend, backend, MongoDB. Backend will be written in Node.js plus TypeScript. Frontend will be written in React plus TypeScript. Database is MongoDB to keep the schema flexible, because in this specific use case, the kind of nodes that we have are going to have fairly varied schema. So you don't want to restrict yourself with a SQL database. In some cases, it's a good idea. In this specific case, it's not the best idea to use an SQL database. Even if you do use an SQL database, you'll probably be dumping very big JSONs in there. So it just makes sense to use a NoSQL database, so that even for JSON dumps that you have in there, you can search on top of them and query things that you might want to. Other than this standard CRUD that we'll be building, we have to build another service called the executor. The executor is the thing that will eventually actually execute these nodes. So whenever the price changes to a certain point, actually sending a long to lighter, sending a short to backpack will be done by the executor. The executor will be receiving these events through a queue from a trigger / polar. We can call it one of many things. The job of this guy is very close to the job of a controller, which is it's basically an infinite loop that is constantly checking, has there been, in this case, 10 minutes passed since the last event. And if it has been more than 10 minutes, then push the respective set of nodes to be executed to this queue. In case a trigger has been fired, in case the user wanted a price, a workflow to run when the price reached a certain point, if that point has been reached, then let the executor know so that the executor can finally execute the thing. The reason they're separate is so that the executor doesn't get overwhelmed in case there's a lot of events happening at the same time, and hence the queue will sort of keep piling those up. In this specific use case, the user doesn't really expect the events to happen immediately. Workflows can happen over time. If they happen over a span of 20 seconds, 30 seconds, it's fine. Which is why in this case, we have a queue which will be storing all the events that have to execute. We can independently scale the executor in case we feel like the queue is becoming really long, or it takes a really long time for the events to execute. In that case, horizontally scale the executor. But in most cases, we won't have too many events running, and hence a single executor would probably just do the trick in our case. The trigger polar. In this case, the kind of nodes that we're supporting, the kind of triggers that we're supporting, if we go back here, there were 2 triggers whenever a price flips or on a specific interval. For a specific interval, we can just have a clock running on this polar or trigger or whatever you want to call it. But since we're supporting the price reaching a certain point, or eventually RSIs or other indicators going above or below a specific number, we do need to pull the current prices of various assets that we support. For example, we might support Bitcoin, we might support the Coinbase stock, or the Nvidia stock or Tesla stock, whatever assets we support. Wherever we want to finally let the user create triggers, which could be the price of the Tesla stock or could be the price of a cryptocurrency asset like Solana or Bitcoin. We need the price feed of that, which let's say every 5 seconds, 10 seconds, 20 seconds, 1 minute, we're grabbing from a respective source. CoinMarketCap, for example, will give you the prices of cryptocurrency prices. The price of an NYC stock can be fetched from Robinhood API. The price of Indian stock can be fetched from the NSE or the Zerodha API. So depending on the kind of stocks that you support, the price triggers that you support, we'll have to take some information every 1 minute, 2 minutes, 20 seconds from these sources, so that the polar, the trigger, this specific service can figure out if a specific trigger needs to run, if a specific workflow has instantiated based on the current price and probably the existing price. If the price ever falls from 151 to 149, that means this Solana below 150 trigger has been achieved, and hence these workflows need to run. So this guy's job is to find what workflows need to run. This guy's job is to actually execute those workflows. The reason they're separate is so that if there's a lot of events that suddenly need to be triggered, these events can be heavy. You're hitting external services, sending emails, maybe hitting Telegram API or hitting an exchange. We want to make sure we process them not in a burst but slowly, which is why there's a queuing sort of an architecture. Else we could just merge these services as well. That would work as well. All right. Hopefully the architecture is clear. A front end, React, backend, Node.js, MongoDB as the database. A service, again, Node.js, Go doesn't really matter. An executor, Node.js, Go, Rust doesn't really matter. A queue, any queue doesn't really matter. SQS, RabbitMQ, Redis, Kafka, and an API from which we're going to fetch the prices. That's the high level set of services that we need to support. With that, let's move on to the next section. The next section was probably the most interesting section over here. Rarely do you find applications where the front end can be a little challenging. This is one such application. So let's start writing the front end of this. Let's start to create a page where the user can come and create these nodes, create these graphs, and try to, show them visually, this is a specific trigger. This is an action that is logging on one exchange, another exchange, and persisting that to a backend. Let's get into that next. All right, let's get into probably the more interesting bit of this video, which is writing the front end for it. Traditionally, it feels like it's very hard to make such a front end because this isn't standard DOM elements that we're dealing with. We're dealing with a graph that looks something like this, where the user can actually move these nodes of the graph and connect one node to another one. So effectively what you're doing is creating a visual graph that looks something like this. This is what N8N looks like. If you go to N8N, you can create workflows, which are very close to the workflows that we're going to create today. We want to allow the user to be able to create a trigger, which in this case is an HTTP request. So whenever there's an incoming HTTP request at a specific endpoint, we allow the user to run these set of nodes one after the other. So whenever this request comes, it'll run this Airtable, probably store an entry in an Airtable database or an Airtable spreadsheet. And once that is done, we want this specific and this specific node to run. Whenever these two nodes run, we want these two nodes to run, so on and so forth. The execution logic comes later on. Right now, we just want to allow the user to come to our website and create various types of nodes and connect them together through edges that similar to the ones that you see on the screen. This seems like a very tough problem. It thankfully isn't, thanks to a library called React Flow. Since we're using React, React Flow is a website that lets you create something like this. So notice there are like various nodes, and the inputs of these nodes is finally deciding the output of the thing that you see over here. Sort of very close to what we need. We need to allow the user to create nodes like these and connect them together. React Flow makes it very easy. N8N does not use React Flow. It uses Vue Flow because they're not based out of React. They're based on top of Vue, but Vue has a similar library called Vue Flow that pretty much lets you do the same thing. Basically, this is like a very common use case that you might, that a company might want. And hence, Vue has a library for it. So does React. This is the one that we're going to use. So let's initialize, go to a kickstart and initialize a fresh React project and add React Flow to it. So I'm going to create a fresh folder. Let's call it trading N8N. Let's initialize a folder here called frontend, where we're going to write the frontend logic. And here I'm going to, I can just go back, delete the frontend folder and run the command bunx create wheat frontend template React. That would create a fresh React application on my on the specific folder in a folder called frontend. So now I have React code in a folder called frontend, where we'll be making all the changes. This is default React code. So if I open this specific project in Cursor, and look at the code, we have a top level source /app.jsx. If I get rid of everything over here and simply return a hi there, that is exactly what I see on the final page. So let me quickly do that. Let me run a npm run or bun run dev. cd frontend bun run dev, bun install bun run dev. I think I exited the terminal a little too quickly, so my bash rc did not completely run. If I try it now, cd frontend bun run dev, I hopefully see a frontend. When I open this, I see hi there written at the middle of the screen, which the reason there is some CSS over here because there is some default CSS that comes in app.css and index.css. We'll change this very quickly. We'll write our own styles. We'll style the whole website ourselves. Right now, we need to focus on adding React Flow as a dependency. Thankfully, they have steps. The next dependency to add is React Flow. That's available on @xflow/react. After you've done that, if you look at their steps, we have to introduce a default CSS file that comes from React Flow. And that's it. That's all that you have to do for the setup procedure. Now that we're set up, we'll have to understand a little bit about how React Flow works. In the end, React Flow creates frontends like these for you. Or if you look at the landing page, frontends like these for you. These frontends are created declaratively. If you understand what that statement means, it basically means that everything over here is a controlled component. Ye bhi thodi jargony statement. Let me pull back a little from the jargon. It basically means you as a developer are supposed to define your nodes and edges. You can define a node by giving it an ID and a position. And if you want to add some metadata to it, add that over here. In this case, we have defined two initial nodes and one initial edge. The edge We've given it an ID of N1, N2 because it's an edge from N1 to N2. We've said the source is going to be the node N1, which is this node right here, and target is going to be the source N2. We have defined our initial set of nodes and edges. Eventually, we want the user to define them. For now, we have defined them ourselves. And then, if you ignore the functions that are written over here, we create two state variables initialized to these initial set of nodes and edges. We create two state variables, nodes and edges, initialized to the initial nodes and the initial edges that we have created upfront. We can keep them empty if we want an empty canvas to begin with. But let's say we just want to try it out, see the default example that they give. Then ignoring these three functions, what they've done is just use the React Flow component and given it the set of nodes and edges. That's good enough to see the first two nodes and an edge between them with very basic minimal styles. So let's try to copy their code. Let's paste it over here. This is the initial set of nodes that we have. This is the initial set of edges that we have. We'll come to what the purpose of these three functions is very soon. But before we reach there, let's see what does this look like on our front end. If I open localhost:5173 now, I see sort of a graph. It has node number 1, node number 2. They are connected. There are a bunch of problems over here. I don't see any labels written inside, which is weird. There probably is a label. I think it's just white in color, which is why, I'm actually not able to read it. If I right click inspect and try to read this guy, probably there is a label somewhere. Yeah, node 1. The problem is it's white in color. So let me just remove all the default styles that we have in index.css and app.css. Now, hopefully, I see node 1 written, I see node 2 written. And it's like a basic set of nodes that I have defined on the top over here. When the user comes to our website, they should be allowed to first select a trigger. I repeat, they should be able to select the very first trigger. Every workflow will have one trigger, one thing that starts the workflow. So initially the graph ideally should be empty. And then they should be allowed to create various edges from it and various actions from it. Any workflow will have one trigger and multiple actions that follow that trigger. So for our website, when the user comes, ideally, they should first select the type of action that they want to create. The type of trigger that they want to create. They might want to create a buy on spot slash sell. Sorry, these are not the triggers. These are the triggers. Buy on a specific interval, let's say 5 minutes. Buy on a specific price flip. When the price of Solana goes above a certain point or below a certain point, that is the trigger for their application. So the first thing that the user should see on our website should not be two default nodes. Should be probably a selector, a model, something like that, that lets the user select. Okay, do they want to create something on an interval, or do they want to create a trigger that triggers on a price flip? So I would probably have an initial empty array over here. We'll come to that soon enough. Abhi ke liye, let's also read through the three functions that they had before we start to, implement the flow for our user. There are three functions that are written over here: on nodes changed, on edges changed, and on connect. The purpose of these three nodes is, assuming the user is going to do a bunch of things on the front end. Let's say this edge did not exist. I repeat, let's say the initial edges was empty. Then we would have two nodes that look something like this. They're not connected. If we ever connect them, then we want this connection to get reflected in this edges state variable. The edges state variable should be updated whenever the user does something. This is what I meant when I said controlled components. The way a lot of input boxes, if you've ever used Material UI, you've probably seen controlled components. The way a lot of external components like these work is they expect you to pass in the state. The problem is a lot of times the state is dictated by them. In this case, if you connect them, the state variable up there called edges is dictated by this component. The component is sort of changing it, which is why we need these three functions. Whenever a user adds a node over here, or if the user adds an edge over here, or if the user basically takes out a handle and tries to connect one node to another, some default apply node changes, apply edge changes, and add edge are exported by React Flow. If you call those, they will return you the new set of edges, the new set of nodes. So whenever a new node is added by the user, or they change an edge, let's say they deleted an edge, then on edges change would get called. Let's say they tried to connect one node to another, then on connect would get called. And inside this guy, we should change this state variable, because if we change the state variable, the component would re-render and the new edge would finally appear over here. If we don't do anything inside these functions, let's say I don't call set edges here. If I don't call set edges here, what would happen is you will try to connect both of these, but the final connection doesn't appear. Why? Because you never really updated your edges state variable. So in the next re-render, a re-render did not even happen because no state variable changed. What you want is whenever a re-render happens or whenever the user tries to update the state, add a new edge or add a new node, we should reflect that to the state variable so that when a re-render happens, the new edge is passed to React Flow and the React Flow actually renders that edge over here, which is why we need these three callback functions. If there is ever a node change, reflect that to this node state variable. That's done through this set nodes function. Whenever there is an edge change, let's say you deleted an edge, reflect that through this set edges state variable, or this edges state variable. And then lastly, whenever there's a connection that is made between two nodes, then call the onConnect function to actually add new edge. That's the purpose of these three callback functions. So hopefully that's clear. How can you allow the user to connect nodes is the only thing that we're seeing right now. What we want to allow the user to do right now is, number one, create a trigger. Create a trigger. The first thing they want the workflow to run on. And then allow the user to create a bunch of actions. We'll do it the same way N8N does it. I'll show an example of how N8N does it. And then we'll follow the same pattern so that the user journey that the user sees is very close to the journey that they see when they're on N8N. So let's get into that next. If we understand how to install React Flow and understand a basic example in it, how can we create a very specific use case of ours? Notice our use case is a little different. If you look at it, our handles, these are called handles that let you connect one node to another. Our handles are vertical. There's one at the top, one at the bottom. Generally for these workflow platforms, for N8N, they're horizontal. The first one doesn't even have an incoming handle. There shouldn't be an incoming handle on the first guy. Everything beyond that can have an incoming handle, can have multiple ongoing handles. But the very first one should only have an outgoing handle. So how can we let the user, number one, choose a trigger and show them a node that only has one handle on the right side, not below, not above, on the right side. And whenever they expand this handle, how can we let the user create node number one, node number two, which has an incoming handle, something like this, and an outgoing handle, something like this. And if they do expand this handle, how can we let them create another node without persisting it to a database yet? Right now, if I make any change and refresh, the change sort of goes away. Persisting it to a database is the simplest thing. You have two state variables, just dump them to a database. Since we're using MongoDB, the database is schemaless. Doesn't matter what the schema of these complicated nodes and edges arrays look like. We can just dump it to a database. The difficult bit is following this specific format. One trigger with one handle, multiple actions with one handle on the left and one handle on the right. So let's get into that next. Let's try to create the user journey for our nodes, for our graphs, for our flow. Let's get into that next. All right, let's finish the user journey. Let me add like React router DOM here really quickly and move all of this to a separate page called, create workflow or something like that. We keep forgetting the imports, but I think it is router, comma, browser, router, comma, routes, comma, route, and return browser out. Let me just turn off cursor here. It'll just confuse everyone, including myself. Page or path, I think, equal to / dashboard, and then element equal to a component called create workflow. And then let me create a new file inside a folder called components. Let me call the file create workflow.tsx. Oh, there's JSX here. Did I not initialize the project correctly? Seems like I didn't. Yeah, let me quickly reinitialize the project in TypeScript. It seems like this project is in JavaScript right now. All right, I created a new folder called client, which has the project and TypeScript. I'm going to get rid of the folder called frontend. And now in this client folder, let me do a bun dev. Let me open localhost colon 5173. And I see nothing, which is not great because I'm not on the dashboard route. So let me open the dashboard route. I sort of see something. I think what I need to do is move this over here, get rid of index.css, get rid of app.css, and then we should be good to go. Back to square one, but in a more cleaner, cleaner fashion. Let me call this route create workflow, inside which we have this guy. Now, I'm going to give it types. But yeah, we don't need this very soon. Initial set of nodes and edges are actually going to be empty. And one thing we're going to do is, if there are no initial set of probably array changes, node change type array. Going to stick to any on these three for now. And what's up here? Come back to this type error soon enough. Any array. Ooh. Think that is because I don't have types here. I do want to put types here. Let me just define my own node type. Interface node type. What would our nodes have? They would have some data. That'll probably be the type of the node. So that could be a bunch of things. For now, the type of the nodes would be, let's look at them. This is like a price trigger node. Actually, it should be of one of two types, which is either an action or a trigger. The first node is the trigger. Every other node is an action. The other thing, actually, let's just, yeah, that's fine. The other thing is that, is it a lighter node where you're going long on lighter or backpack or hyperliquid? So I'll probably call it kind, which could be either price trigger, or which means this thing, or it could be a timer trigger, or it could be of type hyperliquid, or it could be of type, let's say, backpack, or it could be of type lighter, which is the third exchange we're supporting today. What else does a node have? I lost the code that I had here. So let me go back to React flow and look at the schema of the nodes. And it looks something like this. ID string position. Let me just copy that. That looks good to me. And these are going to be of type node type array, node type array. And it's the only one that still has an error. Oh, actually this will be of type edge array, my bad. And we can define a custom edge. Probably I'm going to define a custom edge. Do we need to though? Probably don't. We don't need to define a custom edge. We could just use the edge type from these guys. But I think just for now, in case we do want to add some metadata later, I'm going to define a custom interface called edge, where all three of these are going to be strings. Alrighty, that looks good to me. Cool. All the type errors have gone as well. And now we have a page that looks something like this. There are no initial set of nodes and edges. What are we supposed to do next? Probably add a pop-up as soon as you reach over here on the, sorry, not the dashboard page. I think it's create dash workflow page. Yeah, that's the one. On this page, what we want is a pop-up that the user can choose the type of the trigger from, which is either a timer, this thing right here, or a price trigger, something like this. So I need to introduce some styling library that lets me add models to this front end very easily. What is such a UI library? There are many. I'm going to use ChatCN because it's the easiest one and probably the simplest one. They have this dialog component. If I open this, I see a model pop up. That's exactly what we need. We can also show it in a sidebar. They probably have another component called, this isn't it, navigation menu. Nope. Because that's what these guys have. N8N. N8N has a popper that comes from the right. I forgot the exact name of it, so let me just search that. Right pop over ChatCN. I don't know if this is it. Nope, this isn't it. Right, what do you call that thing? ChatCN component overlay on right side. Not a sidebar, probably a sheet. Yeah, that's the one. That's what we need, because that's exactly what N8N has. If you've ever used N8N, if you want to create a workflow, add a new node, an action or a trigger, it shows you something like this, which I like more than, a pop-up. So let's use that. Step one is just installing ChatCN. So let me open this in a new tab. Let me go to the installation section. Let me select Wheat. Let me add Tailwind. Let me add this to index.css. Let me update tsconfig.json. Let me update tsconfig.app.json. Let me add these types. Let me update wheat.config.json. And I think we're good to go. Let's initialize ChatCN. And while that is happening, let me add the button component. And the, what was it called? Sheet component. And let me create a new component here called trigger sheet, which is supposed to render all the available triggers so the user can choose one of the many available triggers. Export const trigger sheet. The props it would use are probably going to be an on select. So whenever the user selects a specific trigger, which could be one of these two. So let me actually just change this to be in export interface trigger type, or type it trigger type equal to this, and then probably the hell export interface node kind is this. This will be node kind. This will also be node type. Oh, that's not great. Probably not the, actually we don't need this to be a separate type. So all right, node kind is going to be the kind of the node that the user is going to select from, like a drop down, and probably some metadata about the node. For example, if it is a timer node, in that case the user will probably select if they want a 10-second timer, a 1-minute timer, a 2-minute timer. So some metadata which we should create into a strict type eventually. So I'm going to define it, type trigger, or node metadata. I'm going to stick to any for now, but eventually we should probably make this more strict. And what's the problem here? It's not imported. I imported it and we're good to go. What needs to happen here is we need to render a sheet. But before that, what's up here? Am I tripping? Oh yeah, I am tripping. Am I not? Yeah, sorry. Rust TypeScript, slight confusion. You go to this thing. No, it is this. It is an arrow function. What am I saying? Have I forgotten TypeScript? No, there's some other error. That makes sense. Some error here. Ah, fuck. I'm sure you guys saw that before me. Cool. So trigger sheet is the component that we're defining right now. It takes onSelect as an input, which means the user has selected a specific trigger. In our case, there are 2 triggers they can select for now. Eventually, we'll add more. So let's let the user select them through a sheet. Let me copy this default sheet that they have here. Let me use the default code that they have here. Probably don't even need the div. And I think we are good to go, or are we? We probably need the label and the input components. Let's just add them in statcn. And now what we need to do is change the contents here. Select trigger, let the user select it using a drop down. That's not needed, or maybe some description. Select the type trigger that you need. And here we could probably just show them an input box. Not an input box, sorry, a drop down. It's not probably a popover. Select probably. Select is probably the right term for it. Yeah, there we go. So let me add the select component here. Let me import these from select. And that looks decent enough. Description, and then a select, which will have one of 2 values for now, which should probably come from an array, so we can update them later. Const supported underscore triggers equal to title for the trigger is going to be timer. Description, run this trigger every x seconds / minutes. And then there's another one, which one is the title is going to be price trigger probably need an ID here as well. Timer ID price trigger, and then description runs whenever the price goes above or below a certain number for an asset. Perfect. That looks good to me. These are the 2 types of triggers that we support, and for each of these triggers I'm going to add a select item. It has a ID, title, description. Value is going to be the ID. And this side is going to be the title. It's good enough. We don't need the description. All these here my cat just came. Do I need a label? Probably. Let me add the label here. Oh boy. That's probably a good idea. Yeah. Let me do this. Title, and we're good to go. Hopefully. Now, one thing it does select it, probably means on click. On select, I probably need to call on select with the type, which is going to be what it expect again. It expects the kind and the metadata. So kind is going to be the ID, and the metadata is going to get tricky. Let me create a state variable called metadata. It will be different for every trigger. So let me quickly create a state variable called set metadata. Right. I think that's good enough. What's the problem here? These are two arguments, this and that. Type of ID is incorrect. That is very true. It should be inferred from here. We'll fix that eventually. But all right, we have a new component called trigger sheet that opens up whenever the user reaches the page for the first time. So let's do this. If not, let's do it here. Not nodes dot length and render the trigger sheet, or not the trigger sheet, the trigger sheet component on select. Whenever a node is selected, we'll get its kind and metadata, and we're going to do the following. We're going to create a new node. So set nodes, the existing set of nodes, followed by a new node of type node type, which is an ID, which should probably be, or can probably be nodes.length. Can it be? No, probably not. Probably shouldn't be nodes.length. How do we select the ID of a node? Should we select a random string? Probably. Let me just go with mat.random for now, and we'll see how to change that later. We zoom in as we try to fix this. Trigger sheet on select equal to, looks fine to me. Paste it. Function starts over here, ends over O. That's a better error. Data and then kind. All right. So data is going to be position. That should probably do it. I've not yet attached the metadata, which I should. We should have a metadata field here, or should we probably, yeah, metadata, which I defined here, I think. We should just be here with all the other types. I'm going to import it here. And we're good to go, I think. Perfect. What is it? Needs to be here. All right. What's up with you? So I have to do this thing. Cool. What I've done right now is, if there are no nodes, then just force a trigger sheet to open from the right so that the user at least selects the first node. And the component that we've rendered is triggered sheet that will only render one of two sheets. The thing that's missing over here is whenever the user selects a specific sheet, we don't let them decide the metadata just yet, but we will need metadata. Metadata would be what is the time for which they want the trigger to run, the clock to run, or for the other trigger, the price trigger, we need the user to specify what is the asset that they want to run the trigger on and what is the price that the trigger should run on. So those are two things that are missing right now. Let's just see if it works for now, and then we'll go from there. String not not kind. Well, yeah, this is one type error I need to fix. Should be an easy fix. We'll get there when we get there. Let's see what it looks like right now. If I go to create workflow, I click on open and then this shows up. So we don't want that. We don't need a button called open. We can simply say sheet is open, or open equal to probably true. That should be good enough. If the sheet is rendered, it should be open. If I refresh this page, it says select trigger. Select the type of trigger that you need. In our case, you need timer or price checker. The label looks really bad, so I'm going to remove it. Or I'll probably move it niche and add description here. Yeah, I'm not a designer, but I don't love this. Probably can be, yeah, let's remove that for now. It's good enough. Timer or price trigger. And once the timer is rendered, we need to render specific metadata. So now comes the part of writing individual components for the timer and the price trigger. But at least if I click on save changes, do I see one node? I don't see anything. And there shouldn't be a close button here. So let me remove that. Save changes ki jagah it should say create trigger. And lastly, the one thing that, oh yeah, exactly. Let's move that. Or let's add it back. Full width in Tailwind. W-max, I think. Let's wait for the Tailwind docs. I think it's W-full. Yeah. Oh, I wrote max, my bad. There we go. That looks good. Timer, price trigger. Create trigger doesn't do anything. If I right click, inspect, and open the console, I don't see anything. Oh, probably know why. Selected trigger, comma set selected trigger equal to use state. One of the two triggers. So probably the first one supported triggers of 0.id, and then value equal to selected trigger, on click equal to set selected trigger should be that specific trigger, so ID, and then when you click on create trigger is when you should call on select with that ID and metadata, not that ID, selected trigger ID. Oh, my bad. Something like that. That looks good. This is the typo we will fix eventually. Now the question is, does this get called? Because I think it does, which means this gets called, which hopefully means a new note is created. Fresh. Select the price trigger, click on create trigger. I see an alert. I see a node. The node looks very empty, but I do see a node, which is good. And I see arrows coming out of it. That's the first trigger. The problem is it doesn't render the node very well. Probably because I need to give it a better, well, eventually we need proper renderers. But I probably need to give it a better name or a better key over, let's see. Label. So data can have a label, the string. Let's just add a label, which is going to be the kind. And now if I look at this, refresh, select the price, or timer is fine. I see timer, refresh. Can I not select price trigger? I can't for some reason. So let's see, on select is the ID and then select trigger. Timer, and if I click on this, it still remains timer, even though this is called. Why is that? On select never gets called. I can probably select on click. Still doesn't work. On click was also used. Still didn't work. Why is that? Probably needs to be something like this. On change. And we can probably get rid of this. Right, if I refresh now and I select price trigger and I click on create trigger, I see a price trigger here. Let me remove the alert. Refresh again. When I come to the create workflow screen for the first time, I need to select the trigger. I select price trigger, click on create trigger. I see the very first trigger. And from here is where we have to, let the user design their workflow. Simple enough. Next up, we have to do some slightly weird React flow things. A few common things are the trigger appears over here when the trigger should appear on the left and the right. For the action, it should only appear on the right. I repeat, for the action, if I open an N8N, demo, or if I open an N8N image for you, a workflow, this one, for example, you will notice that if you look at the image, the very first one only has what's called a handle on the right. Everything else has one handle on the left and one handle on the right, which basically means we need some level of custom nodes. We need one node or one type of node, which is the first type, and the other type of node, which is the second type. So let's add all of that logic next. Any previous knowledge is not going to help here. We need to dive a little deeper into how N8N nodes work, and basically not N8N nodes, basically how React Flow works. A bunch of React Flow jargon, a bunch of diving deeper into small things about N8N. For example, one thing that happens on N8N, small things about React Flow. For example, the one thing that happens in N8N, if I open my example, is that if you pull out from one of the nodes, the other node sheet opens from the right, and you can select what node you want to add. So the next thing I need to do is whenever the user clicks on one of the handles and spreads it out, a sheet opens on the right and they can select the action that they want to do from here. So move these handles to the left and the right. For an action, the left and the right. For a trigger, only on the right. What is a trigger? The very first thing that you see here. What is an action? The things that you see after that, which has a left and a right thing as well. Do all of these two things. After we're done with both of these things, is when we need to run the next logic of if the user pulls out a node from here, we let them add another node, another node, another node, so on and so forth. So let's get into that next. I'm going to call the next section React Flow Jankiness. Righty, let's write some custom node logic. Let's try to create the two type of nodes that we have, trigger nodes and action nodes. I'm going to create a new folder called nodes, inside which I'm probably going to create another folder called trigger and another folder called actions, probably triggers and actions. And the very first type of node that we need to support. So every node needs to look different, right? Yeah, visually a so less than 150 node should look very different from a node which is a timer. Should have some sort of a clock over here. They should probably have a lighter logo, a backpack logo, and hence I'm probably going to create a different node component for each one of these. The very first one I'm going to create is, let's say, the timer.tsx, which basically needs to create the logic of a visual representation of the node. Eventually we'll make it, we'll probably add some inputs, some props that it'll accept. Right now, just a component just to make sure when the user selects a timer, they see the timer node. This node specifically needs to have one handle on the right. It does not need to have one handle on the left and one on the right, just one on the right. So I'm going to first add a new handle over here, which comes from React Flow xflow/React, which is the React Flow library. I'm unsure. Let's custom handles React Flow. Let's look at the logic of how you create a custom node. When we say custom node, we mean just a visually customized node compared to the default node that we saw until this point. What does it expect as an input? Probably expects position, right? Yeah, that looks fine. Right position. Oh, it's an enum, so probably position dot right. And the inputs are probably going to be, we'll have to look at the documentation honestly, what exactly does a node receive. So there you go, custom node with the position dot top. That's fine. It does need to accept some inputs though. Let's see, this doesn't have any inputs either. Customization nodes. There you go, props. What do the props look like? Let's try to figure out. Let's go to the code. Color select a node. Data and is connectable are the two inputs. I have to figure out the types. Data is probably the thing that appears over here. So data.metadata is what we're worried about. The timer node metadata would look something like this. The time, which could be a number. Let's say it's a string for now. And the inputs that we receive, data is going to be metadata, which is of type timer node metadata. Is connectable. The name sort of tells me is a Boolean. I don't think we're worried about the second variable anyways. Handle on the right, and probably data.metadata.time is what we're worried about here. Type equal to custom handles. Oh, this is going to be a source. Yeah, that looks fine. The timer is going to be a source, which means nodes edges are going to come out of it. That's a decent enough node. We should probably, add some padding here, some border, which again I forgot. Tailwind border. How do you add some? Yeah, border is good enough. And let's see what that looks like. Let's also create another one called price trigger, whose data would look something like this. The method would look like the asset and the price, and probably the decimals, which basically means for Solana, asset would be Solana or Sol, whatever the symbol is. Price would, let's say, be 150, 00000, and decimals would be 6, because whenever you represent prices, you don't represent them as, you always represent them as integers, and you have another field called decimals, which is the extra number of zeros that you've added, which is also known as the precision. So you can just use the price, but in that case, it'll be a floating point number that could lead to floating point errors, which is why, we're supporting. Actually, let's just keep this simple. Let's just, select the dollar price, and eventually we can worry about adding precision. All right, what I need to show is probably the name of the asset and then the price. Alrighty, now that we have these two, let me export these types. And in our drawer that we created, or sheet that we created, the metadata that we send will be one of these two types. So the metadata will either be price trigger metadata, or it will be timer node metadata, or it'll, yeah, I guess that's fine. And then let's just default it to something like, oh boy, this would probably be in seconds. So 3600 seconds, that's like, is 3600 seconds an hour? Yeah, I think so. And let's make this a number over here. Every these many seconds is when this trigger would run. That's perfect. And over here, I probably need to add, for now, a bunch of if-else statements. We can make it better. Based on what the user selected, which means if selected trigger is of type timer, let us select a type. If the selected trigger is of type the other one, which is going to be price dash trigger, I think in that case, render an input box or a drop down with a bunch of assets. So this will basically be a select, very close to this one. Metadata dot asset on value change set metadata the asset, which is going to be value That is fine. Need to fix that though. You can make the types more stricter to get away of this error. Let's just stick with it for now. Select a fruit. It should say select a trigger, and this should say select an asset. And then lastly, what values do you have here? Let's just add an array. Probably should exist in the backend eventually, but for now here, supported assets equal to Sol, BTC, ETH, let's say. These are the three assets that we support for the person to buy. All of this logic should be in a separate file, I think, because as we add more and more types of triggers, this will get very complicated. So we should fix that. Basically, I'm just shoving everything in the same file. Supported assets.map, just the ID and the ID. That's good enough. And then the other thing the user might want to select is the number. So the other thing that we want here is the asset, which will be an input box, but probably a Stratsion input box, type equal to number. I don't know if that's supported, probably not. On change equal to set metadata and then the asset and the price e.target.value. That should be good enough. Convert that to a number. Alrighty, that looks good. That's metadata is propagated up the chain to the node, and then it's rendered on the node in these custom nodes that we have created. For example, timer.tsx. The only thing that's left now is I've defined the nodes. Node number 1, timer, how it visually looks basically. The price trigger node, I've also, whenever the user comes on the screen, let's try that. Whenever the user comes to create a workflow, and if they select price trigger, they can put in a price and an asset. If they select timer, is when also they need to select how many seconds. So let me just add that as well. That should probably do it. If I now refresh and let's see input box. Why don't I see an input box right after this? Because pretty sure I saw them on the other one. Price. Input type equal to text. Oh, my bad. This is an input type text. On change equal to e.target.value. This will be e. And I think we're good to go. Now I see, hopefully, time, number of things after which the timer should run. This can be a slider or something else. And when the user clicks on create trigger, a node is created, but it's not a custom node. It still has handles upper niche. We don't want that. We want the handle to appear on the right. We want something custom to be rendered on the node. So if I go back to probably the main page, so that's create workflow.tsx, I need to tell this React flow component the type of nodes that I have. So if you look at the custom nodes logic here, when you do render these custom nodes, you need to give it the types of nodes that you have. And in our case, we have two types of nodes. Well, we'll have more. We only have two right now, which is the two actions or two triggers that we have. So import price trigger and import the other one, which is timer. Yeah, that looks good. And types are going to be, if it is of type price dash trigger. Oh, there we go. That's a big problem, isn't it? I think this type field over here means a lot of things. I think this type field here is what N8N will pick when it tries to map one node type to one node kind to a visual node, and hence I should probably just rename these. Node kind should appear over here, and this thing should appear over here. Just change the names of the things, nothing else. That also means kind would be this, and this would just be type. And we don't need the label anymore, so I'm going to get rid of the label. And I think that should be it. Yeah, that looks good to me. Cool. Now I can say you're going to render this guy. Price trigger. And what's the other one? Timer trigger. It's going to be timer. That's all we need. These node types are what we need to forward to this guy. And now I think the node should just render correctly. What have I done? I've given the two types of nodes that we support right now. It's basically the two types of triggers, really. We need to add more types of nodes, the action nodes, but the two triggers that we support are price trigger, timer trigger. And since whenever you create a new node, this callback gets called and we set the type over here to be one of price trigger or timer. That's exactly what gets stored in this nodes array, which is what we pass over here. So when the final thing gets rendered, it checks, these are the two types of nodes that we support, price trigger and timer trigger, and renders the right one accordingly. So if I go back here and refresh and try to add a timer, I see a weird looking node here. So that doesn't look great. Let's see. Node types and then nodes ID. Oh, it should exist outside. The type should exist outside the data. So type should exist outside the data, and I think that's it. If I go back here now and add a new timer, you don't see it. ID, type, data, and position. ID, type, position, and data. And based on the type, it should render the right thing. So what I'm going to do now is quickly render the nodes array. And what I see is ID type timer. Oh, type is timer. Why am I returning the wrong type? That's why you need better types. In my trigger sheet, yeah, probably over here, I should just rename this to price. Yeah, this is like really bad types I have. Timer and price. Price trigger is a better name for this, but timer is a better name for this. And same things here. Price trigger is fine, but it should be timer. All right, we had different names. I was passing the wrong thing. The logger helped me. And now there you go. We have every 1 second this node should run. We can make it prettier. But if I come to this sheet and select a timer, I see a timer node. If I come to this sheet and select price trigger, and let's say select a price of $150 for Solana, I see Sol 150, which basically means we're rendering the other node, which was the price trigger node, this one right here. It doesn't look great right now. We can fix that. Copy vibe, fix the UI once for all at the end. But there you go. We have the node. And now comes the next difficult part, which is when the user pulls this and leaves it over here. We need to allow them to create not a trigger, but an action. That's all we need for the front end. Mota mota. I mean, of course, we should make it prettier. We need authentication pages, yada, yada, yada. But the primary logic, if you look at it, involves you allowing the user to do exactly this, which is when they come to the screen for the first time, they can select what is their trigger. And once they've gone through the trigger and created their very first node, it should have a handle on the right. And it should allow the user to add multiple nodes after that, each one of them being actions. That's what we're supposed to do next. Supposed to add a bunch of actions. And more technically, the way to add actions is when the user pulls this and leaves it, is when the sheet should open again and the user should be able to pick one of many actions. So that's what we're going to do next. It's the exact workflow or the exact UX that you find if you're ever using N8N. So let's get into that next. Let's start to create the actions now that we've created the trigger. All right, let's write the logic that if you pull this trigger out and drop, a new node appears that you can select the type of the node and the other metadata associated with that node. The good thing about React Flow, and it's not very easy to do, but after some trial and error, I was able to find one way for you to figure out if a node was stretched and then eventually left at a weakest spot, not when one was being connected to another node, but when a node was pulled out from and then left at a weakest spot. To do that, on connect end, there is an event that gets fired on connect end, which, as the name suggests, is an event that gets fired when you try to connect something and then you leave your mouse pointer. Basically means that you try to create a connection and it ended. Might have ended in a node, might have ended in a weakest spot like this. The parameters that you get from here, one such parameter is the connection info parameter, which if you try to log, you can find more info around, what exactly does this event give you. So let's see what info we get whenever the user pulls a node and then, eventually leaves the node over here. If I refresh, see a bunch of type errors, which one of the errors is that I don't have an argument to the use callback function. The other one we'll have to see. Probably need to give it types. Let's select a trigger node. Let's pull this out. And if I right click, inspect, look at the console, what I see is an object which has a bunch of properties. From is going to be important, or probably at least from handle or from node is probably going to be very important, which means the node that you sort of pulled this handle out from. So from node dot ID is going to be one important thing. The other important thing is going to be, let's see, probably this where you try to finally place it. This will be important because the new node that is created, we need to give it a location. So dot 2, and then the last one is going to be probably the ID of the node that you started from, which hopefully can be found somewhere here. No, I can't find it. Oh, dot data dot from node dot ID. There you go. Oh, it's already there. The ID is there. The 2 is there. Yeah, the last thing that we need is, was this thing dropped to another node or was this dropped to a weakest spot? If it was dropped to a weakest spot, that probably means that the user wants to create a new node. For that, there is a field over here called, I think, is valid or something like that. Yeah, there we go, is valid. If connection info dot is valid, that means the user tried to drop it to a valid spot. But if that is not true, that means the user left this handler in some vacant spot. If they did leave it in a vacant spot is when we want a write draw to open, where the user is going to select the type of the action and what they want to do. So if the user drops this thing out in the vacant spot, this if statement gets reached, which is where we need to open a write handle again. This time, not a create a trigger sheet handler, but a trigger action sheet handler is what we need. So if I copy everything in trigger sheet, paste it here, I will add a new array called supported actions. One supported action is, let's say, create long, which means, what were the types here? Hyperliquid, backpack, and lighter. Yeah, that's the one, hyperliquid, which means the user wants to place a trade on hyperliquid, place a trade on hyperliquid, and then let's add another one for lighter. Place a trade on lighter, and then lastly, let's add one for backpack as well. In all three of these, for now we only have trading actions. The metadata would look very similar. Supported assets is something that should just be exported from one place. So let's just export it from here. And even for these actions, we'll need some metadata. The metadata would look probably very similar for all three. So let me define that in a new action node. Let me call this one backpack.tsx, even though all three of them will look the same. So let me first create lighter.tsx, export function lighter. This is a lighter trading node, which would again receive some data where there will be some metadata, which will be of type lighter metadata. Actually, it should just be of type trading metadata. Here, I would specify what all the user would specify, which would be type. They might want to long or they might want to short this a specific asset. Then let's say the quantity, which would be a number. How much do they want to long or short? And then the asset or the symbol, which again, if you remember, we defined this type somewhere. I think here. So type of supported assets. Is it not exported? It is exported. At slash components slash sheet supported assets. We need the type of supported assets. There we go. Lighter, which would return again a pretty looking node where we need to probably show a lighter, logo. Let me just lighter trade for now, and then maybe show some parts of what this is, which is going to be a long or a short div, the type, the quantity, and the symbol, which all come from data.metadata. Oh, is it easy? There we go. Alrighty, that looks good to me. If I go back to the action sheet, the action sheet, we we want the metadata to finally look like this trade metadata. We want the selected action in this case, not the trigger, but the selected action to be of type selected actions of zero.id. Let's say the very first one that the user might want is to place an order on Hyperliquid. And we can probably leave this as null initially because the user might want to specify, what kind of a trade they want to make eventually. Cool. The supported actions, we want to map the title user can select, and then comes the metadata. Right now, irrespective of if it is of type Hyperliquid or basically doesn't matter in all three of these cases, we want the same thing to happen, which is that we want the user to be able to select the quantity, how much Solana they want to buy, or long or short, the price at which they want to long or short. Do we even need the price over here? Probably not. Just the quantity, the type, and the symbol. That's it. So quantity, type, and the symbol. Type and symbol would both be selects. So type is just going to be a select over all the assets that we have. And then the third one was symbol. Symbol is going to be a select on all the symbols that we support, and type is going to be long or short. So let's just add a select statement here. Which is going to let the user select amongst long and short. Metadata dot type. Should add a question mark here. Set metadata. Yeah, we should probably not initialize this to null, but an empty object just to keep things simpler for now. This would be either long or short, so that's not too difficult. ID equal to long, and then this is going to show long, or the user might want to short. There we go. The symbol would be again a select statement. We should probably clean this up a little. The code is becoming longer than I'd like for it to be. Select on change metadata. This would change to the type. It would be the value, and then another select. Which is going to be on the assets that we support. So this section would change to selected, supported assets.map asset like this, and this would just be the asset. Key would just be the asset, and then this would also just be the asset. There we go. Cool. What's wrong here? I don't see anything wrong particularly. There we go. Cool. That's the second select. And whenever this changes, we want the asset type, the asset symbol to be this value. Alrighty, that looks good. Quantity, whenever this changes, we want the quantity to become e.target.value. That's it. That's the only type of action that we support right now. Another one I would like to add would be sending out emails, but let's finish this one first and then we can add more. Cool. Button on click, selected action. We need to fix this. Okay. Should also change to selected trigger everywhere. Oh no, it is an action. My bad. On select. kind, node kind, which would be one of these. That looks fine. Metadata would be node metadata, which is any for now, or is it? Doesn't need to be any. No, probably doesn't need to be any. It will just be of type. Where is this create workflow? I will stick to this for now, but we can actually change this to be either of trading metadata or the other ones, which were, price trigger metadata, or the last one, which is, what's the third one? Let's see. It would be timer metadata. All right, that's probably a better type for node metadata. And action sheet looks good to me. On select looks good to me. What we want now is in create workflow, whenever the user reaches over here, we want the write sheet to open up. So that would mean const select action comma set select action equal to use state null. We don't want to select anything initially, but whenever the user does point at a specific point, we want this action to open up. So here I'm going to add a specific type, which looks like this. X, the position where we want the final node to appear, which will be a number. Y, which will also be a number, or it could just be, position XY, which is probably a better way to put it. Starting node ID, which will be a string, I think could also be a number. It should be a string. And lastly, it would be the X and the Y, the starting node ID. And I think that's it. Yeah, that should be it. Or null. Over here, if it is valid, I want to set select action to be starting node ID and position. This is where things get tricky. Was this the position? I think so. I'll still log it. But I think this was the position. I could be wrong. We'll see. Actually, I can just check the type. On connect end. What is your type? On connect end, event, connection state, final connection state, which looks something like, oh boy, connection state. Is valid from to XY position, which is XY. Perfect. So that's fine. If I go back here, that should open the sheet if I do something like this. This is the one check we need for the action sheet. The other check we need for the trigger sheet. The other check that we need for the action sheet is if select action is present is when we need to render the action sheet, which is it not exported? Action sheet. Let me search for trigger to this file. Select action trigger. Yeah, these are fine. Sheet and on select here would be a little tricky. Set nodes. Initial set of nodes. Okay. Const node ID equal to, again, a random string for now. We should change that. And then the type is going to be the type that comes back, which is fine. Position is going to be wherever the user left. The selected action dot position. And then metadata can just be metadata. I think we're fine. I think that's all we need. Am I right? Probably. No, we need one more thing. We need to create an edge between the old node and the new node, which is exactly what I was missing here. Oh, no, we do have starting node ID. So the other thing that we need is set edges, and we need to create a new edge now. And what does the edge schema look like? Actually, I forgot. Source is going to be select action dot start node ID. Think, what's the other thing? Edge, ID, source, and target. All right. ID can just be source and target. So target is going to be this newly created node, so node ID, and then ID for this edge is going to be, I mean, it could be anything. I'm going to give it an ID that looks like this, which is the starting node ID to the target. I don't think the ID would matter in the long run anyways. And that's it. That should create an edge probably. Let's see, let's test it out. There's no other way to know if we're right other than testing it. If I come to this screen, I can create a trigger. If I pull this out, I can select an action. Let's say I select lighter. There's some problem with backpack. Let's say I select long. Let's say I select sole. That does nothing. Quantity. Bunch of problems. Let's fix them. The action sheet should also trigger something if we have backpack. That's one. That's why I need an enum over here and not a string. Number two, the symbol is not being put. So let's look at the symbol. Select an asset, and then this one should be select a symbol. Separate assets. Yeah, that's fine. And this should change to symbol value. And dot symbol is what I meant. That should probably do it. Perfect. If I open this or create this not trigger action, then what happens? Oh, things break. Very good. Cannot read property of undefined reading X. Alrighty. I should probably render the node somewhere to see what's up. What I'm going to do is do a console.log on nodes and edges. And let's see. Redaction. Okay, so nodes look something like this, which mostly looks fine to me. I don't think, oh, position undefined. There we go. Did I forget to put the position for the newly created node? I don't think so. I did put a position here. That probably means selected action has some issues. Refresh. Create trigger. This thing. Starting node ID is there. Position is not there. Starting node ID is there. Position is not there. From node dot two is what I wrote. And what was the weird type here? Let's see. On connect end. This thing right here. This thing right here. This thing right here. And there is a from. There is a from node as well. From is what we need though. Or do we? From node dot. Okay, let's just go with from for now. I think that's a position. Try that again. There you go. Position looks fine. And if I click on create action, I do see another node. Need a bunch of other things. After all of this is done, set selected node action to null. Let's try that one more time. A timer every 1 second. I want what? I want a BTC long on Hyperliquid with a quantity of 10. Create action, and I see a bunch of things that don't look great to me. Number one, the handles are weird. So let's go back to our node. Oh wait, I haven't created nodes for everything. I also not added them here. Let's add backpack over here. And hopefully, no, let's add lighter over here. Let's add lighter node over here. And this one doesn't seem to have handles, which it should. We need both a source and a target. Target on the left, source on the right. That looks good to me. Yeah, and probably can just copy paste this to a backpack and a Hyperliquid node for now. For Hyperliquid, the only thing that would change is lighter would get replaced with Hyperliquid, and everything else is fine. Probably don't need this. We can just import it. Same is true for backpack. This would get replaced with backpack, and then this would get imported. Perfect. I think that should do it. Fresh. Select an action. Pull it out. Hyperliquid long sol one quantity. That looks wrong because I have not added the types here. We have lighter, we should have backpack, and then we should have the third one, which was Hyperliquid. Now this looks like a good node. The only problem is the XY is a little messed up. Probably because I'm choosing the XYs very incorrectly. Why am I choosing from node? I need to pick the point where the user dropped the thing, right? Not the point, the node where they started from. So what I'm going to do now is go to console. Oh, there's a bunch of logs here, which I can remove. The log that I need right now is connection info again. Because it's going to tell me, hopefully where I drop the pin from pointer to 2 is probably the thing that we need. Just 2 over here. And let's try that one more time. Create a node. And oh boy, that's a little further than I was hoping for. All right, let me do this for now. Position x dot x plus position underscore offset, and then y is going to be the same thing plus position underscore offset. We should make this better. For now, I have a variable called position offset, which is 200. It will just be 200 pixels further off from the original node. Let's try that. Refresh. 200 every 0.0555 second. What the fuck is here? There's something up here. Let's go back here. Let's go to our sheet. Which sheet? Trigger sheet. And let's try to see what's up. Time number, that should be fine. Let's go to the renderer, which is, timer.tsx. Yeah, this is the number of seconds. That's what we're taking from the users. Every 200 seconds, do what? On Hyperliquid, do a long on BTC with a quantity of 1. And oh boy, it's really far. So position offset is not going to be as big as 200. Probably going to be a little lesser, let's say 20, or maybe, I don't know. Yeah, 20 is good, I guess. 30 is slightly better. If I do this and create a node, we need to refresh. If I do this and create a new node, long sol on Hyperliquid, still is a lot. Wow. So probably 10 then, or maybe 2 then, maybe 5 then. 5 is probably better. Let's try that. Still a lot. Something is up here. It shouldn't be that bad. Hyperliquid, short, sold, quantity of 2. Still pretty bad. Correction not from, but X plus. Oh, my bad. It was a Y. There we go. Such an idiot. This will be 200. This needs to be a Y. Refresh, add, pull it out a little, and then let's try that. Yeah, a little further this time, but yeah, I can just make this 50 and we should be good to go. Let's try this again. Yeah, that looks decent enough. 50 seems like a pretty solid number. One thing I would like is that it literally is at the spot in which the guy pulled. For example, right now, this sort of works. If I pull it in the direction below, it'll sort of look okay. But if I pull it above, it'll feel a little weird. So we should figure out how to figure out, the final spot and just render the thing over there. All right, we have a screen where the user can come, select the very first node, pull out a node from here, add an action. If they want, they can add another action, which we only support 3 trading actions for now. Eventually we can increase the list. And now we need to execute them. Probably need to let the user save them. And once the user saves them, start executing them every 3600 seconds in this case. Does that mean we can move on to the backend? Probably. One or a few things to add would be authentication. But that might be it. Well, credentials is another thing, but we'll get there after the backend is finished. The front end part of creating nodes is done, which was the difficult bit here. We can make it prettier now. We need to add authentication pages. We need to add a dashboard, things like these, where the user can track all their workflows. But a workflow builder is done, a place where the user can come and select one trigger and multiple actions. Now, I'm going to make this very pretty by probably just asking AI to do a round of, prettifying the thing. After that is done, I am going to probably move on to the backend. So let's do that next. Let's see how good AI is in wipe coding. Can you keep the current structure as such and only make a better design? Do not change the current structure. So it'll just add a bunch of tailwind classes and hopefully will not touch any of the things that we've written so that the code remains the same. But a bunch of tailwind classes make our UI a little prettier. Right. Can't say it made it super pretty. I think it just moved things a little bit around, which is fine. But yeah, I think we'll move on to the backend now. Now that the front end is done, we're able to create a workflow. Let's think about what the backend might look like. How would you store a graph like this in the backend? And how would you actually execute this graph? In this case, in every 1 second, how can we execute a few things missing over here, but a shot of BTC on Hyperliquid, followed by a shot on Lighter. How will you finally execute this in the backend? So if you remember the architecture, and if I probably change this a little bit, even though there's a lot to do in the front end still, we're done with step 2 and we're moving on to step 3, where we have to write a bunch of auth routes followed by syncing the workflow to the front end. Should be easy. Credentials is something we haven't done yet, and the executor. So let's move on to that next. Let's move on to writing the backend for this application. Right, one quick thing I want to do before we move to the backend is monorepofy the whole thing. The problem is there is a lot of types that the frontend and backend should share, probably should have shared already. So I want to make sure there is some level of a monorepo, maybe a turbo repo, so that the types are shared between the frontend and the backend, and I'm not repeating types everywhere. So I'm going to sprint through this. You'll see this in a fast forward section. No code is changing. The only thing that's changing is the frontend is becoming an app in a monorepo, or more specifically a turbo repo. And the reason we're doing that is so that the frontend and the backend can share types and there's not a lot of code duplication of types throughout. All right, I'm going to sprint through this. All right, what I've done is I've created a fresh monorepo. It only has one app right now, which is our client. And amongst the packages, there's only the ESLint and the TypeScript config. I'm now going to introduce a new package called common, where I'm going to add a bunch of the types that should probably be shared between the front end and the backend. So one init inside it, followed by finding where the types exist in the client. So if I open source slash probably nodes slash actions slash hyperliquid lighter. Yeah. So trading metadata is one, which I probably want on the backend eventually. Yes. So I'm going to remove it from here, move it to common slash index. I'll create a new folder here called metadata slash index.ts. And this is where I'll add all the metadata types. So there is trading metadata, which uses supported assets. So let me move that here as well. And what else? The other metadatas, which would probably be in nodes slash, so this one right here, that's timer node metadata. And then there is price trigger metadata. Let me export all of this. So index.js would export star from dot slash metadata. Oh. That should be good enough. And in package.json, I'm going to add a section called exports dot slash types dot slash index.ts. That would export everything from this package to both the front ends and the backends. Right now, I'm going to just add a dependency in the front end. Backend isn't initialized yet. So in the front end, let me add a new dependency called, let's see, common, which in case of bun, I think is star, or could be workspace star. I'm unsure. I think it's star though. Let's do a global bun install. Let's go to one of these nodes and let's try to import this. Import from common slash types. And it says should be imported as a type. That looks good enough to me. Let's do the same thing here. Import type from common, and then all the other places we're using it. So in the actions, this should come from common slash types. And this should also come from common slash types. And this will probably be used in all three of these nodes: hyperliquid, backpack, and then I think app.tsx is fine. Create workflow. Few things have changed. So this is where you should probably use AI. It'll make you much faster. You don't have to do this by hand. There we go. And then lastly, trigger sheet. Yep, same thing. And create workflow is fine. Action sheet, same thing. I think that should be good enough. Supported actions. Yeah, it should probably also exist in a separate file. If not the common folder. I think the common folder is fine. We have a few types in there. There are a few other things I would want to structure better, but we'll get there when we get there. For now, let's just make sure the app is running as expected. So apps/client bun dev. And if I go to /create workflow, it looks closer to what it was before. So I think we're fine. Let's move on to writing the backend now. All right, I'm going to initialize a new app now called backend, cd backend, bun init. And after we've initialized a new backend folder, I'm going to add express as one of the dependencies and try to quickly finish the first part over here, which is writing the authentication routes. The other thing I want to add is JSON web token and add types /JSON web token for generating the token on the backend for a user. We're going to simply create a JWT token based on a username and a password, keep things super simple. The one more thing I need to add over here is the database, which ideally should exist in packages because it will probably be shared by the executor as well as the primary backend. So let me actually, before writing anything else, let me just create a structure of the endpoints we need to support. Then we'll move on to the database logic and write the types for our database. Then we'll come back to the backend and finish it. So let's quickly write a structure of all the backend endpoints we need to support. Right, I think that might be an exhaustive list. I could be wrong. There might be more endpoints to add here. Sign up, sign in, basic authentication routes, a route to create a workflow. So whenever you're on the front end and you click on publish or something like that, this endpoint gets hit. If you're ever updating a workflow, if you're on an existing workflow, click on the update workflow button. This is the endpoint that gets hit. If you want to get the full graph of a workflow, the existing graph, if I am on a specific workflow, I refresh the page. I want to see the full graph. I'll get it from the backend of the database. This endpoint exposes that. If I want to get all the executions of a workflow, if a workflow has been running every 1 hour, then in one day it'll have 24 executions. I probably want to see how much time did it take to execute, what all things were executed, was there an error in the execution, so on and so forth. So that will be exposed by this guy. Credentials, post and get. This is something we haven't added on the front end, but to allow the user to trade on their Hyperliquid, they need to share their Hyperliquid credentials with us, which could be an API key, could be a private key, whatever the specific platform requires. So we have to write a lot of this logic. This will probably be a separate section over here of creating credentials whenever we reach there. I've just exposed the endpoint for now. And that's it. The other thing around credentials is the schema of credentials will be very different for every platform. Hyperliquid might only support an API key. Lighter might support an API key and a private key. Backpack might support username and password. If you want to add a send email node, that will support the SMTP credentials, so on and so forth. So the credential schema is going to look very complicated. And hence, there's some database schema things we have to do over there. We'll reach there when we reach there. Let's first just try to finish authentication as well as the create workflow and sync it to the front end. So whenever there's a workflow I've created over here, if I refresh, I should still see the workflow present over here. It should be persisted on the backend. Fairly simple CRUD basically, persisting this graph on a backend. All right, before that, we have to introduce a database and write the schema of our application. So let's try to deduce what should the schema of this application look like. We'll spend some time writing the schema, and then we'll spend some time, writing all the types for the schema, which we can eventually use over here. So let's get into that next. Let's get into defining the schema of this application. All right, let's try to devise the schema of our application. There will definitely be a users table. We'll simply have an ID, which will be an object ID in case of MongoDB, or you can consider it to be a string. We'll have a username and a password. That's pretty much it for the users table. We don't have to complicate things here. Ideally, we should hash the password. I'll probably not do that to keep things simple. But ideally, you should hash the password before storing it. Whenever a user creates a workflow, there will be a workflows table where we'll create an entry. This would have an ID for the workflow, a user ID, which user created this specific workflow, a nodes type, which will be a very big, JSON blob, and then an edges type, which will also be a very big JSON blob. The nodes and edges will internally have every node's metadata, associated metadata, so that whenever the executor needs to execute a workflow, it gets it from here. So the good thing over here is, since we're using a schema-less database, we're using MongoDB, we don't have to worry too much about the types that go inside here, the schema of nodes and edges and what it looks like. You can simply resort to any, because this will get really complicated really quickly. As you add more types of nodes, the schema of nodes and edges becomes fairly complicated. You probably don't want to write the database schema for each and every node and type, even though you can. We've sort of written a variation of that in, this commons folder that we wrote. This is sort of, what the metadata looks like for all the individual nodes. For a trading node, it looks like this. For a timer node, it looks like this. Writing the Mongoose types of this may or may not be a good idea. We're not doing that today. So we're going to simply resort to any. That might be it, unless I'm missing something. I think the workflow should just contain the graph. Then comes the credentials table. You'll probably have before the credentials table a credentials type table, which basically, actually, do we need this? We probably do need this. Yeah, basically needs to store what all credentials types we support for various providers. So ideally, every node type should also be in this database. Ideally, these metadata should also be in a database, honestly. But let's say we don't do that. I'm going to write node type, or actually, let's just stick to credentials type for now, where we'll have an ID. Actually, we probably need node type here as well. Do we? I'm thinking. Yeah, we probably do. Supported nodes and supported actions probably needs to be another type. So let me quickly add that. Basically, we have a bunch of in-memory variables. So if you go to, action sheet, you will see we have these three, this like as an array. This should exist in a database. The kind of nodes that we support shouldn't be an in-memory array. It will become really hard to add more nodes over time. This should probably exist in a database. So we're going to have a, let's say, a actions database, or sorry, table, or in case of MongoDB collection. And we're going to have a triggers collection, the kind of triggers and actions we support. Or we can have a single nodes collection where we have a type. So this will be the ID of the node. This will be a title of the node. There will be a description of the node. What else did we have here? Title, description, ID. Then we should probably have the type. Is it an action, which will be an enum basically, or is it a trigger? And then after we're done with that, after we have all the nodes present over here, this nodes database, we probably need to expose the nodes as well. So in the backend, let me add, app.get /nodes / nodes is fine. Basically should return all the supported nodes that we have, which basically hits this database and gets all the nodes to the user. And now we can write the credentials logic. Let me, color that separately. This and this table. Actually, supported credentials can actually be an array here. Yeah, let's write this credential type. It's going to be an array, which means what type of credentials does the user need to provide us for this specific node. If they are creating a Hyperliquid node, they need to provide us an API key. If they're supporting a backpack node, they need to provide us a backpack username and password, let's say. If they're supporting an email node, they need to provide us a SMTP username, password, URL, so on and so forth. So whenever a user creates a new type of a node, they need to define their credentials type. Basically means what does the credential need to look like for the user for this specific type of node. So in case of, this will basically be again an array of any, but it should actually be an array of something like this, title and then type, which could be either a string or let's say a number. Most of the times it will be a string. So the nodes, let me just show you what a nodes row might look like. It looks something like this. ID1, title, Hyperliquid. Description, this is a Hyperliquid node that lets you create a trade on Hyperliquid. Type would be, this is an action. And then lastly, credentials type would look something like this. It will have one field that the user needs to provide us, which is title, API key, and then type would be string. We can make this more complicated. We can add another type here. Is it optional or not for the user to provide this? So we should probably add that. Required, which is a Boolean, whether or not the user needs to specify this specific type when they're creating a node. When they're creating a hyperliquid node, they are required to provide us a API, an API key required true. Now, whenever the user is creating a node, yeah, this is where things will get a little complicated. Whenever the user is creating a node, they will probably provide us credentials as well. So a nodes schema would look something like this. Let's try to write this. Nodes will it'll actually be an array, and so will edges. And the array of nodes would look something like this. Let's see. Let's go back to create workflow. Probably have a node type here, right? There you go. So its type would be basically a foreign key to the nodes table, something like this. What type of node this is. Then there would be the data, which actually can be inferred from here. So we probably don't need to put it, but let's just put it still. Action or trigger. Sorry, data would be kind, action or trigger, and then metadata, which is the any type that we have, which pretty much could be anything because it'll be very different for each and every one of it'll be very different for each and every node, which is why sticking to any just makes sense here. Let me make this a little bigger. ID I already have. Yeah, we should give it a a user generated ID. Every node should also have some sort of an ID, which can be a string or an object ID, and then lastly position, which will be again X number, Y number. So one more thing we need to add here is the credentials. So the user will provide us the credentials of in case of a hyperliquid node, hyperliquid, in case of a lighter node, lighter. And ideally, the schema of this should look like this. There are ways we can enforce this, but again, since we're using a schema-less database, we're just hoping we'll have all the checks needed on the backend to ensure before data reaches the database, we do validation on the backend side. So there are two things that could go wrong here. Wherever you use any over here or over here, things can go bad. The database might have corrupted data. You might require the user to provide an API key for a node, but the user might not specify it. They can hit the backend with whatever credentials they want. We need to add validation over there and check if they're trying to create a hyperliquid node, then they should have provided us a hyperliquid API key, things like these. So on the backend, we should have some more strict checks because on the database side, we don't have a lot of strict checks, specifically when it comes to this and this. This is the other benefit of using a NoSQL database. We were able to basically make the schema less complicated. If the same thing we were doing in an SQL database, we would probably have a separate credentials table, a separate user credentials table, so on and so forth. Things would just get tricky. In this case, nodes drive. Yeah, in this case also, yeah, I think this is good enough. There's just one small problem here. I'll share what the problem is. Basically, when you go to N8N, you can basically put lighter credentials in one place once and then reuse them across nodes. In our case, we expect the user to, for every time they create a lighter node, provide us their API key, which is fine. We can fix that with another database over here or another table over here or another collection over here. I'm trying to remove that complication. So in our case, whenever the user creates a lighter node, they need to provide us the lighter API key, irrespective of if they're creating it once or 5 times. In case of N8N, they can just create credentials once and then just reuse those credentials everywhere. And if they change the credentials, they get changed everywhere. That probably is a good thing to add, but I'm not going to add it today. Yeah, for this video, I'm going to stick to a schema that looks something like this, fairly simple, not too complicated. And we can always move to allowing the user to store credentials separately. All right, this also changes some things on the front end. When the user goes to the front end and tries to create a node, they will have a separate section here called credentials where they can put the API key credentials in case of lighter, put the username and password in case of backpack, so on and so forth. So along with these inputs, the user needs to provide us the credentials inputs, which right now they need to paste again and again for every node. Eventually, we can have a separate sections called credentials, where the user can reuse those credentials across nodes. All right, that means the schema is enough. There's one last thing that is left, which is going to be, can you guess it? It's going to be executions, which basically stores what all executions we made, in the last whatever XYZ time. Whenever the executor actually executes something, it'll put an entry here just so we can track all the executions. So an ID for the execution. What specific workflow was it executing? So workflow ID, maybe some logs, or at the very least a status, which could be pending or success or failure. And then probably start time and end time might be two other things. That's it. That should be a decent schema of our application. I need to convert these to Mongo types now, or Mongoose types now, which is the next step. But before that, let's think, are we missing something? User logs in, user can create a workflow. A workflow can have multiple nodes and edges. These nodes need to be of one of these types. So every node that we add needs to exist in a database and needs to clearly tell is it an action or a trigger and what credentials type it supports or needs. It might not need any credentials. It might need a very complicated credentials array. And then when the user creates the nodes, they specify the credentials along with the node for that specific node. For the edges, again, we can make the schema a little more strict. What does an edge look like? ID, source, and target. So that's pretty simple. ID string, source string, and then target string. I think that's good enough. That's all we need for the schema. The nodes have been created, the workflow has been created, the execution will be created over here. If there is something more, we'll get there as we start to build the application. But I think for a V1, this schema works. So let's start to convert this visual schema into types in Mongoose so that we have slight more, type checking on the backend. It makes it a little easy for us to convert, connect the backend to the database. So the next step is going to be adding a new package over here called probably DB, where we're going to add all of our Mongo and Mongoose types. Alrighty, let's start coding this. I already created a folder in the packages folder called DB. Let me do a bun init. Let me do a bun add Mongoose, which is the library, the ODM technically that lets me connect to my MongoDB database. I think we need types for this as well, if I'm not wrong. And that's it. Let me open db/index.ts, and here we'll define our schema and export it. In package.json, let me again add a section called exports /client /index.ts. Now everything that I export from here, I can import it in the backend. The things that we're going to add are these. So let's kick things off with import Mongoose, schema from Mongoose. If you've used Mongoose before, if you've done the merge stack, I'm assuming this is like not too difficult to define the schema of your application and export it. The users table would look something like this: const user schema equal to, I think it's new schema, if I'm not wrong. This is a class, yeah, with the respective fields, which in our case include username and password. Username, which is type string required true. This is one way to write it. The other way to write it is this. You can pick and choose. You can be a little more granular if you make it an object, which is what we're going to do. Password, again, type string required true, and that's it. That's how you would define the user schema. And what you export from here is not the schema, but something called the user model, which I think is done like this: mongoose.model. The name of the model, which in our case is, let's say, going to be user. When we say the name of the model, you can think of it like the name of the table or the name of the collection. And we provided the schema. This user model object, now I can use in my code to create new entries from find one specific entry from so on and so forth. So it becomes very close to an ORM. It lets me query my MongoDB database and, fetch things from there, insert things over there, update things over there, delete things over there. That's the simplest one, user schema. Now comes, I think next one should be probably so for an ID here. So I'd probably go with workflow next. Const workflow schema equal to user ID. Now this is where things get tricky. This needs to be a foreign key or a reference to this table. And I need to specify that in the schema. It's been a while since I've done that. Type would be the type of an ID over here. I've not provided an ID, but the type of an ID is something called an object ID in MongoDB. Hopefully, if you've done MongoDB, you already know this. There's a very specific type of an ID, which is commonly known as the object ID, which is automatically added over here. So the thing that reaches the database is not just username and password, but an ID field. What I want to do here is the type would be not a string, but an object ID, which I think comes from mongoose.types.object ID. I think this is the right type. Required true references, I think. Let's Google that, references in Mongoose. Ref the users table. So in the users table, the users table ID is what this user ID references, which means it's closer to a foreign key relationship, where this user ID should in fact exist in this users table. And this will refer to a user in this users table. So in the users collection, there are 10 users. Every workflow needs to be a relationship, or needs to be a one-to-many relationship. Every user can have many workflows. Every workflow will belong to a single user. And that was the difficult one. User ID is done. Nodes and edges. Nodes is going to be an array, and edges is going to be an array of a very complicated type, which we can define separately. We can also define it over here, but I think it just makes sense to define the nodes schema separately and the edges schema separately. Let's start with the simple one, edges. So const edges schema equal to new schema. I think you can do this for better structuring. I could be wrong. We'll see. And I think the one thing you have to do here is pass, I think, underscore ID as false, which means we don't want the edges schema to have an auto-generated ID. We just want to, show the schema separately. We don't want it to automatically generate an ID whenever we're creating a new edge, because the ID already comes from the front end, right? ID, this will be a string because it's coming from the front end. Again, we can make it a little better. Type string, required true, followed by source, which is again the same thing, and then target, which is again the same thing. Now this is where we're not being too strict. We're not really checking does the source and the target exists in the nodes array. We have to do that at the application level. So whenever we're writing the backend endpoint that lets the user create a workflow or update a workflow graph, we should check on the backend, are these valid edges or not? Do these nodes exist or not? Are we not putting an arrow into the the trigger? The trigger can only be a source and not a target. So checks like these need to happen at the backend level. We're not doing these checks at the database level. This will be an array of edges schema, which was the simpler one. Nodes becomes the more complicated one. So let's write that next. Type, which should be a foreign key to the nodes array. So type will be, it's called type also. Type will be mongoose.types.object ID, and it will reference something in the nodes array. Are we using plurals? We're not using plurals. Let's just stick with node. A node array, or sorry, the node table. Ideally, everything should be plural. So I would say this needs to be users, and this needs to be nodes whenever we define it. We have not yet defined this collection. We've only defined this collection. We're now defining this one. When we reach here is when, we'll call it nodes and not node. And this should be users and not user. Type is this thing. What else? Data, which will have a kind, which will be a string, but it will be an enum, which could be one of two values, either action or trigger. This is an extra field. It already exists over here. So ideally, we shouldn't redefine it here. There is some data redundancy in our schema right now. We can fix that. And lastly, metadata, which the type is actually going to be mongoose.types.mixed. I think, how do you define the mixed type? Basically means anything. Because this can be one of many things, the metadata will be very different for every node. We're basically asking it to be anything. Mixed, there you go. Schema.type.mixed. This is equivalent to an any, which means the metadata field can be anything. Anything is accepted and can go into the database. We can add some type inference later to, add some strictness. But for now, two fields, if you remember, are going to be any. One of them is this field. The other one is this field. Every node will have an ID for the front end, which will be again type string required true ID, position and credentials. Position will have, let's say, be of type position schema, which will look something like this. And the position is done. Credentials will be of type any or mixed. Required, not really required, honestly. So we can simply do this also. Some nodes might not just require any metadata. Probably, I don't know. Should be optional, I think. This is good. We have an ID. So this is the front-end generated ID. This is not the object ID. This is not like an auto-generated ID by MongoDB. This is a front-end generated ID that we use just to, that is eventually used in the edges schema as, either a source or a target. This becomes nodes schema. I think that should cover this thing right here. I could be wrong. Let's confirm once. This edges nodes user ID. Edges is fine. Nodes has type data, which is either action or, oh, okay, it's a little weird. Sorry, my bad. Yeah, that was wrong. Data will have a kind and a metadata. So const node data schema equal to new schema. And this will have kind and metadata. So yeah. Yeah, that looks fine. Node data schema will have a kind and a metadata field. Data is this thing. ID is a string. Position is position schema. Credentials is mixed. I think we have everything. And edges also, I think, looks fine. Great. Workflow schema is done. Let's create a workflow model. This is where AI should be super helpful. Workflows. All right, I think that should do it. We're done with the workflow schema and the user schema. What's left is the nodes and the execution schema. Let's start off with the node schema. It has a title, description, type, and credentials type. Title. Nodes schema gives me a red squiggly because I've already defined it. This is... Is this the node schema? ID, position. Oh, this is this node schema. This is this node schema. Let's call it workflow node schema. This will be node schema now. Title is done. Description, which is a string. Followed by type, which is a string. Or technically an enum, which can be one of two things: action or trigger. Credentials type is credentials type schema. Which will have a title, a type, and a required. So title, a type, and a required. This will be a Boolean. Type would be an enum. It could be either string or a number. You know what? A string is probably good enough here. Yeah, there's no need of a type. Assume every credential needs to be a string. Yeah, let's just remove type from here. Let's just assume every credential that the user provides us. Makes sense. Can be a string, right? An API key, a username, a password, an SMTP URL. These things are all strings, so it doesn't really make sense to have a type here and make things more complicated. Credentials type schema is done, which is going to come over here, and that's it. We're done with the node schema. So export const nodes model equal to mongoose dot model nodes node schema. Lastly, we need the executions, which should be simple. The simplest one, execution schema equal to new schema. It has a workflow ID, which is a foreign key. So workflow ID. And it references the workflows table. Then we have status, which is type string enum pending, comma success, comma failure. Then we have the start time, which is type. Is there a date type in MongoDB? Let's see. There we go. There is a date type. And this may not be required. Is there a default type here? Something like this. I don't know if this is right. We should check. And end time. This will be required. But end time doesn't need to be required because end time would not exist until the execution has finished. All right, that's the execution schema. Let's execute execution schema, and this will be executions. There we go. We've exported 4 collections over here. Collection number 1, 2, 3, and 4. I think I've done everything right. I could, of course, be wrong. We will know once. I mean, the best thing we can do is we can take this graph and take the schema and ask ChatGPT to quickly verify it. Is this correct? Hopefully, if I'm missing something, it tells me. Short answer, almost correct. A few important things that are left. Position schema, user string, a number. That's probably not the worst thing in the world. Position schema should probably be an integer. Number. I think type number is right over here. Number in Mongoose. There you go, number. So that's fine. What else? Credentials type inside of schema should be an array and not a single object. That is indeed correct. That is one thing I missed. Every node can have multiple credentials that they require from the user. For example, a backpack node might require a username and a password. So it will can have more than 1 entries. That is correct. Thank you, AI. What else? The workflow node type is incorrect. Okay. Work node field, but this diagram says, yeah, that indeed looks incorrect. Workflow node schemas type. So a workflow node schema, which is this thing right here. Its type is actually this. That looks fine to me, even though we can probably name it better. It should probably be called node ID. Yeah, it's probably a better name for it, because that's exactly what it is. Node ID. Let me change that here. Yep, that looks fine. And I think AI was incorrect on this. But the diagram says, no, this looks fine. I think AI is incorrect here. I could be wrong. Correct version type string enum. No, that's definitely incorrect. At least on the workflow node, which is this thing. Oh, which is this thing right here. Yeah, that's fine. Node schema missing ID string. That's not needed. Nodes schema. Oh, hold on. Yeah, I think it'll come by default. So that's fine. Workflow node stores an ID string but does not have an internal underscore ID. That is files. Yes, that is correct. Exactly what we want. Edges and node are incorrect. Metadata is any, so that's correct. No, what's wrong here? Edges and node are correct. Then why do you have an exclamation here? Minor node. Metadata is any. So yeah, that's perfect. All right. Minor changes here. I think we're fine. The biggest one was this. The credential type should be an array of credential type schema. Everything else looks fine. Cool. We have a user schema, an edges schema, a node data schema, a workflow schema. We have a lot of them. Even though I just wrote them, I forgot most of them. But I think I covered all corners. If not, we will know soon enough as I write the backend of it next. Let's quickly try one thing. Let's go to backend package.json. Let's add DB as a dependency here. Let's do a global one install. Let's go to apps/backend. In the backend /index.ts, let me quickly import user schema from db/client user model, I guess. Let me try to do a user model dot create. That looks fine to me. Seems like everything is working. let me do import Mongoose from Mongoose and do a mongoose.connect process.env.mongo_URL. We'll add that in the env file. Next, at least types wise, we are good. User model is imported correctly in the backend now. Now that the database package is done, the schema is done basically, we can start to write the business logic. We have a very long file in which we're writing this. Ideally, you should split this up. We can probably do that eventually, but for now, we have all the things that are needed to store things in the database. We have a bunch of API routes to implement next. So let's get into that next. Let's start to implement the backend. All right, let's start coding the business logic. This should be simple enough. I might just sprint through this again. I'll write all of it, but I'm assuming this is fairly simple for you guys to write. Writing a simple backend, at least, a sign up endpoint, a sign in endpoint, a workflow endpoint. What I'm going to do is let me quickly create the sign up endpoint with you guys. Then we'll sprint through the rest of the endpoints, at least the easy ones, and then we'll go from there. Generally, it's a good idea for you to define all of your input types and validate them so that you know the user is sending the right thing. So what I'm going to do is in our common package, add a new folder called types, add a index.ts file here where I'm going to define my requested supported inputs and outputs, at least inputs from the user. Whenever the user is going to hit an HTTP request, the input that they're going to send, I'm going to validate using these types. So I'm going to add Zod as a dependency. I'm going to import Z from Zod and write the types for all of these inputs. For example, for the sign up endpoint, the input should look something like this. It should have a username, which will be a string, and a password, which should also be a string. If you want, you can add more constraints here, but this is good enough. Constraints like these, like minimum length should be 3, maximum length should be 100, things like these. I'm going to export this. I'm also going to, I don't need to infer the type, so let's not go there. This is good enough, I think. I also have to do one more thing, which is export this from index.ts. So export star from /types. I just have to do this once. And now if I go back to the backend, I can import this Zod validation schema. So user sign up schema from common /types. And whenever the user sends me a request, I'm first going to validate the request against the schema. So const success, data equal to sign up schema dot safe parse rec.body. So whatever input the user is sending me, I'm going to parse it first. And if it is not successful, which means the user sent me some wrong data, they did not send me the password, the password was too long, username was too long, anything like that, I'm going to return immediately and send them a add status code, probably a 403. If everything is right though, then we make an entry for the user. Now the thing is, one thing I haven't done, which I should have done, was when we defined the schema, so db/index.ts, we probably want the user's username to be unique. So let me add that here. We need to ensure that the username of the user is unique, which is, I think, a property we can add. Yeah. So now all I have to do is user schema or user model, my bad, dot create username and password. Username is going to be data.username. Password is going to be data.password. Whatever inputs the user sent me, the username and password is what I'm going to put in the DB. This might fail because the user might send a username that already exists in the database. And hence I'm going to put this inside a try catch. And in case things go bad, I'm going to give them a status code of 411 and tell them username already exists. Most of the times this should only fail if the username already exists. It can also fail for other reasons. there's a big assumption here that if this request fails to the database, it's happening because the username is incorrect, which will be true 99% of the times, but sometimes something else might go wrong. If everything is fine though, we can return the user their user ID. So const user equal to this thing, followed by sending them their newly created user ID. Perfect. So that's what the sign up endpoint looks like. Let's try to test this. After I'm done testing this and showing you the full flows, when I'll start to write the other endpoints. To be able to test this, I need to do what? I need to get myself a MongoDB URL. I can get it from MongoDB cloud, or I can start it locally using Postgres. I'm just going to get it from MongoDB cloud. So if you go to accounts.mongodb.com and try to sign in via Google, GitHub, whatever, you can actually create one mini database for yourself. When I say mini database, I mean it's a shared database, which means probably don't try using it in production. But for testing purposes, it's a good, cloud database to try out what the latency might look like, or, what a real request might look like. If you're ever connected to MongoDB, you can also start MongoDB locally because MongoDB is open source. This is just the easier way to, start a MongoDB on the cloud and then test things over there. So after I've signed up to MongoDB cloud, I am going to create a new free MongoDB database. I'm going to call it automation app. I'm going to start in Mumbai and click on create deployment. This should create a free MongoDB instance for me. And these are the credentials of my MongoDB instance. So if you have MongoDB Compass locally, which is a GUI that lets you visualize your database, you can go to MongoDB Compass and notice it tells you a few things. My current IP address has been added to enable local connectivity, which means this database is only accessible from my IP. If you want, you can make this database open to other IPs. If you want it open from everywhere, is when you can add 0.0.0.0/ or just click on allow access from everywhere. If you click on that, then this database is accessible from everywhere, which is okay for testing purposes, but in production, you should probably do something else. Once that is done, you have whitelisted your IP. You can connect to the database using create database user, choose a connection method. In my case, I want to connect via MongoDB Compass. And once I select that, it gives me a MongoDB URL that I can copy and paste over here. When I do that, is when I can visualize my newly created database. Right now, it has nothing. It has a bunch of sample dummy tables or databases. Now I'm going to introduce a new database. This is the credentials for me to connect to my MongoDB database. I could have started it locally, in which case it would have been running on localhost. In this case, I'm running it on a cloud server. And why that is good is because for free, I'm able to test my MongoDB, implementation, is data being stored, so on and so forth. So let me create a env file where I'm going to put a Mongo URL, which is equal to the URL that I just got. I'm going to add the table name at the end, which is going to be, in my case, let's call it again, automation app. That's going to be the name of my table. So that's what will appear over here finally. Let's call it automation_app. This is my database. Whenever I add a new entry over here, or whenever the sign up endpoint actually succeeds, inside the database, I'll be able to see a user's collection where the username and password would exist. So let's try that out. Let's see if the sign up endpoint works as expected. If I go to apps/backend, let me also add app.use express.json because we are using rec.body over here, and you can only parse JSON body if you're using this middleware. If I start the backend and go to Postman and try to send a request to localhost:3000/signup, let's see if a user actually persists in my database. So the username, let's say, is going to be something like this. Password is going to be something like this. Let me click on send. It returns me an ID. If I go to MongoDB Compass and refresh, I see a new table called, or a new database called automation app, inside which I see executions, nodes, workflows, and users has one entry over here. If I try to create another user with the same username, it says username already exists, which is beautiful. So that is how you would create the sign up endpoint. Hopefully that's clear. What did I do to create the sign up endpoint? I added the schema in the common interface. Why did I add it in the common package? Because we might need some of these types in the front end. May or may not need it. Generally a good idea to put everything that may be needed on the front end and the back end in a common place. That's why we have kept it here. Then we do some basic checks to ensure the user has sent us the right things. If they have, then we put an entry in the database, return the user their ID. Let me quickly create sign in next, and then probably I'll sprint through all of these. For sign in, it'll look pretty much very similar. One quick call out here, we should hash the password, which I've not done right now. I'll leave it as an exercise for you. The sign up schema and the sign in schema will look the same. So I don't necessarily have to declare a separate type here, but let me do that. And let me import that. And if the user doesn't send us the right inputs, we send the same thing. Now I need to find a user who has this username and password. And if user exists is when I will return the user their JWT/token. If the user doesn't exist is when I'll send them a bad status code and tell them, hey, your credentials are incorrect. But if the user does exist is when I don't want to return them just their user ID. I want to return them their JWT, a token that they can use for future requests to authenticate. So hopefully we already know this, how a CRUD application works or how authentication in a CRUD application works. Whenever the user signs in, they get back a token. There are various ways to create these tokens. One of the ways is to use a JSON web token because it's stateless and has its own benefits. We already added JWT as a dependency, if you remember initially. So I can just import that here and sign a token for the user. I'm going to sign their user ID with a secret that I'm going to add in the .env file because, well, it is a secret and you don't want it in your application code. So you can write JWT secret here and define it as a global variable at the top. We create the token and we return them not just their user ID, but also a token. You actually don't even need to return them their user ID, just the token is good enough. That's what the sign in endpoint should have looked like. Seems like I've done this logic in the sign up endpoint. So let me change that. There we go. Let's see if sign in works as expected or not. It seems like, it should. I don't think I've done anything wrong here. It's pretty simple stuff. So if I now try to go to Postman, try to sign up, username already exists. If I try to sign in, it returns me a token. If I sign in with the wrong credentials, then it returns me incorrect credentials, which is beautiful. Both the auth endpoints are working as expected. Every other endpoint that you see to create a workflow, update a workflow, get a workflow, get the executions of a workflow, we don't need these anymore. Yay. Or do we? We probably need a few admin endpoints, which we'll get to when we get to, but the user doesn't need any credentials, so we can get rid of these. We do need get/nodes. Let me keep this active. Other than this last endpoint, every other endpoint needs to be authenticated, which means we need to introduce a middleware in our application. So let me add a middleware.ts. If you have not done middlewares, you should read about them. I think there are a lot of resources on how authentication should be done in an Express application. If you do read that, you'll understand about what is a JSON web token and what are middlewares. Think of these like prerequisites before proceeding. I'm going to write a middleware that does authentication for us. Pretty simple. Again, this is something you'll do many times if you create a full stack application. In Node.js, request, response, next function, const header =. So what the user is going to do is in any future request, they're going to send us a token for authenticated requests to create a workflow, get the workflow. In the header, they'll send us their authorization token, or basically the token that we sent them during the sign-in endpoint, or when they hit the sign-in endpoint. You can get that token, the authorization token, by using rec.headers of authorization. Rec.headers contains all the headers that the user is sending us. We expect them to send us an authorization header, and then we can call jwt.verify to actually verify if this header is correct, given this JWT secret, which again comes from the env file. The problem is header may or may not exist, but let's just typecast it to a string for now. But the header's type is actually fairly complicated. Let's not go there though. If we verify this, we get back a response, hopefully, if everything is fine. If it isn't, then it'll throw an exception, which means the header is incorrect. If it does throw an exception, we want the request to end right then and there. So we're going to send a 403 status code and say, you are not logged in, but if the user is logged in. What we're going to do is extract the user's ID, which is going to be response.id, because that is exactly what we signed in the token. When we were signing the token, we signed this object with an ID. When the user resends that token to us, when we verify the JWT, that's exactly what we get back. Again, the problem over here is the type of this guy is a little complicated. So we can typecast it to JWT payload, and then we're good to go. What we do after this point again is a little Express specific or Node.js specific, which is we set a new key on the request object so that whenever the future endpoints are hit, for example, if I use the auth middleware here and here, we have to use it here and here. In all four of these, if the control ever reaches here, you know for a fact rec.userid will contain the user's ID. So I can set the user's ID over here and then call the next function, which means whenever a request comes to post workflow, it'll first go through the authentication workflow, authentication middleware. It'll go through all of these steps. If everything is fine, is when the request object will be populated with a user ID. So when the request comes here, request.userid would exist. And that would mean request, you know what is the user that is trying to create this workflow. So when you put things in the database, you know for a fact this is the user that's trying to create a new workflow because you have the user ID extracted from the header. The only problem in this is user ID by default doesn't exist on the request object. And to get around this, there's a fairly common way, which is you can create a new declaration file, call it anything, index.t.ts, request.t.ts, index.t.ts. If you don't know what declaration files are, it's a TypeScript specific concept. Just Google, how to override express request type, and you'll find a Stack Overflow that I usually look at as well, because I keep forgetting the syntax of this. But that's how you change the type of the request object so that TypeScript doesn't complain. Things wouldn't really matter. The worst thing that's happening over here is you see a red squiggly. But if you really want the thing to compile, you have to change the type of the global request object and add user ID as an optional field over there, because it may or may not exist. That is what, takes away the type error, because now the global request object, this thing right here, has another field added, which is the user ID, which is an optional string, and hence you can add it over here. That also means you can access it over here. The problem is its type is going to be string or undefined, but in actuality, we know for a fact it will exist, because if it has gone through the authentication middleware, that means it's gone here, 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 and here. We know for a fact that the user ID was set over here. That means we know for a fact user ID would exist over here. So we can add an exclamation here that basically changes the type to string. That's just us telling the TypeScript compiler that user ID does indeed exist. Beautiful. So now we have access to the user ID in the workflow endpoints, all the other endpoints. Next up, we roll up our sleeves. As I try to code everything else, I'll probably fast forward it really quickly. Otherwise the video will become really long. It'll probably be another 30-40 minutes of work, I think, going through these 1, 2, 3, 4, 5 endpoints. So let me quickly fill these. The only thing I'll change structurally would be, I will add a bunch of types here for the input schema of these endpoints. The input schema will be a little tricky because it'll have nodes and edges, but if you remember, we've already written these types in the database or even in the front end. So we already know what the types are going to look like. So it shouldn't be too difficult to write the Zod schemas for it. So I'm going to now finish everything from here to here, which basically means I'm going to finish all the backend endpoints. You'll see a fast forwarded version with probably a song playing in the background. So you'll see a 1 hour video trimmed down to like the next 5 minutes where I'm finishing these endpoints. Feel free to slow it down if you'd like to follow the whole thing. All right, I've basically converted the nodes and edges types that we had written in the past over here into a Zod object. We can actually infer the actual underlying TypeScript type from this Zod object. And we can actually get rid of this definition that I have over here. This definition also is a little more strict. It had a few things here, but yeah, right now we basically have, duplication of types. We should probably converge them at some point. I'm not going to touch it right now.
A few moments later.
Right, I've written all the CRUD endpoints. Nothing much changed, honestly. I mean, if you've written any backend in OneStack before, and if you understood the sign up and sign in endpoint, these are fairly simple. I haven't tested them though. What I've done is the user will send us some input over here to create a workflow. We're going to validate the schema and everything looks good. Is when we create a workflow, let the user know the workflow ID. So let's test that out. Let me sign in as the user. Let me copy the credentials. Let me add them to an authorization header. Let me change the body and send a post request to workflow. Okay, so workflow endpoint is a little tricky. So I'm just going to have empty nodes and empty edges for now. And eventually we'll make it better. We'll add a more comprehensive workflow. Let's add just one empty workflow for now. That means no nodes and no edges. If I send this request, it takes a long time. That scares me a little. Something crashed, nothing crashed. That's taking longer than I would hope. So there's definitely something wrong. There's a try, there's a catch. Both of them do a rest.json. Yeah, something is up here. Probably the auth middleware is what's failing. Oh, no O's here. I think we're fine. Time to log debug. Put a log in the auth header. Put a log here. Let's try that one more time. It worked this time. I'm assuming MongoDB was just not MongoDBing, as in the server was not accessible. That's my only guess as to why it didn't work the last time. Now, if I try to create a few workflows, I created 4 of these. Let me confirm they actually exist. If I go to if I go to workflows, I do see 1, 2, 3, 4, 5 workflows here, which is great. The next thing is testing the other endpoints, which is an endpoint to update a workflow and endpoint to get the workflow, so on and so forth. The problem is we have decided that all the nodes schemas are going to exist in the database. If you remember, when we created the schema, we created this nodes collection where we're going to add all the types of nodes. Let's say we only support, a trigger that runs every 5 seconds, something like that. And an action that lets you place a trait on any of the indexes that we discussed. So let me add those 2 to the nodes before we proceed and try the other endpoints. I'm going to go to nodes over here and quickly try to confirm what the schema was. So there's a title, description, type, and credentials type. Add data, an auto-generated ID, followed by a title, which is going to be for the action is going to be a timer, and then description, run a workflow every X seconds, followed by type. This is it an action? it is an action. No, it is a trigger. And you don't need any credentials for this. So credentials type is going to be an empty array. That's the very first node, which is a trigger. And then we need an action, which is going to be, let's say, the place a long on a lighter, basically trade on lighter. So title is going to be trade on lighter, followed by description is going to be place a trade on lighter. Title can just be lighter exchange, followed by type is going to be this time an action, followed by credentials type is going to be an array of objects. Title is going to be API key, and required is going to be true. Whenever the user creates a node for a lighter, a lighter node to place a trade, they need to give us their API key so we can place an order on their behalf, which is why the credentials array looks something like this. Seems like there is something incorrect here. We'll try to debug what that is. Just an extra comma, it seems, which I'm going to remove. Type action credentials type is this thing. Okay, let me remove that. That looks fine. What's wrong here? Credentials type is an array of objects with the title API key required true. Oh, double quotes here and double quotes here. Perfect. Great, we have two nodes over here. Let's see if the final endpoint that I created, which was this nodes endpoint, which is unauthenticated, does that work or not? So localhost 3000/nodes should return me both of the nodes, and indeed it does. It returns me the timer node, which is a trigger, and the lighter exchange node, which is an action. Given this, we know I can actually start to, send a post request to actually add some nodes and edges. So let's say the very first node is the timer trigger. So the schema is going to look as follows. Poof, a lot of things. Type, it is a trigger. And an ID, let's give it an ID of 1. And position, let's give it a random position. X is 0, Y is 0. Followed by data, which is, oh, this type is actually probably a foreign key, is it? Nodes doesn't have a type anymore. It has if you remember the MongoDB schema, nodes now has a field called, let's see, workflow node ID and not type. So this is going to be node ID, which is going to be the ID of the very first timer node, which is this one right here. And data is going to be kind and metadata. Data is going to be kind and metadata. So kind would be trigger, and there is no need of any metadata over here because, oh well, there's every 5 seconds we want this node to run. This is how complicated eventually the nodes array on the front end would become. Let's try just that. Let's try one nodes entry, It says incorrect inputs. So here comes the first problem. The good thing is if you're using Zod for because this should be node ID. Try that again, and this time it still returns me incorrect inputs. Nodes and edges. Firstly, the create and the update schema should be the same. And secondly, node ID is a string. ID is a string. My bad. Send it again. And this time again, it's incorrect inputs. Node ID, position, X and Y number, position, X and Y number, and data. Oh, there you go. This needs to be action and trigger. This needs to be action and trigger. All right, let's try that now. And we get back an ID for our workflow. And if I go to MongoDB Compass and try to see the workflows, hopefully a recent workflow actually has some nodes. There you go. That looks something like this. It doesn't have an edge right now. Let me quickly add edges as well. So for that, we need another node. Let me add that. Nodes is an array. The second one would look very close to the first one. Node ID would be the ID of the lighter exchange. Its type is an action. Position could be anything. Node ID that says to kind action. Metadata would be, type long and then quantity, let's say 100. And one more thing we need here is the credentials, right? If you go back to the database, the nodes schema does have credentials. So the create workflow, every node needs to have credentials, which can be anything, but probably an array of anything. Credentials mixed. Actually, if I think about it, it can just be an object, right? So z.any works here. And I need to add the same thing when you're trying to update. And over here, I'm going to add credentials also, which are going to be, API underscore key, which is some random lighter API key. Lastly, I'm going to add an edge, ID1, source, let's see, source 1, and then target 2, which is, an edge from this node with an ID 1 to this node with an ID 2. If I click on send, that's what I expected. Doesn't work immediately, probably because I forgot to restart the app. Let me try that again. Again, incorrect inputs. Let's see. Let me remove credentials from the second one and see if that fixes it. Does not fix it. The second node seems to have created a problem. Node ID, position, data, kind, action, and metadata. It looks fine. Nothing seems weird here. What if I remove the second node? Does that work? That doesn't work either. That probably means something is wrong with the edges. Edges have a source and a target and an ID, which is a string. My bad. Send it again. Now, I've tried to put a more complicated workflow in the MongoDB database. And if I look at it, I have one edge and two, I know it's a little hard to read, but if you see this, I have two nodes and one edge stored in a very clean fashion in my MongoDB database. That's why this is a good choice for this specific application to use MongoDB, because it's been very easy for me to store everything in the database. If you've got the credentials, it has an API key, which is beautiful, which is exactly what we need. Great. I think that means create workflow is working. I would assume update workflow would work as well. Then we don't need to test it. In executions, we can only test after we've created the executor. Get workflow might be another one I want to try, but I think again should be simple enough. Although, if not workflow, or yeah, there you go. If workflow's user ID is not equal to the user's user ID, then let the user know workflow not found, because you don't want any random user to be able to access a different user's workflow. So that should be good enough. Executions should probably have something similar. I don't know if executions have a user ID though. This will get tricky. To make sure the workflow belongs to the user. That's a check we need to add. Yeah, but that's probably an easy way to do it. We'll add that. Abhikle, this is a slightly vulnerable endpoint, and then nodes. That should finish the backend, I think. That's all we need. Maybe one more endpoint I'd like to add would be show me all of my workflows. So app.get/workflows, and yeah, find all my workflows and return them to me. Probably don't need all its information, just the ID is good, but it's fine as well. Great. Let me try this endpoint. I'm curious if this endpoint works. Probably should. /workflows. It is a GET request. And indeed, it returns me all of the workflows that I have, which is great. So that I have a page on the front end when I can show all of these. Beautiful. I think the backend is done. I would have ideally at this point taken a pause and written tests for all the endpoints. Maybe structured the endpoints into various files, so on and so forth, even though it's like 150 lines of code, so it's not too bad. The next part is connecting the front end to the backend and completing the front end. If I go back to what we were doing, we've basically been able to, in the backend, add the auth routes. Syncing to the front end is left, credential creation is done, executor is left. So next up, we'll basically do this, syncing the backend to the front end and probably completing the front end. The problem is the front end doesn't have an authentication endpoint, doesn't have a dashboard page where I can, see all of my existing workflows, things like these. So next up, I'm going to pretty much finish the front end and sync the front end to the backend. I'll see you in the next section. All right, I've made a few changes. I've coded a bunch of these, especially the front end pages. And we have a functioning application, but that also required not just creating the front end and connecting it to the back end, a bunch of structural changes that some of you might have already thought of. I just thought of as I was finishing the app that I'm going to talk through now. The very first thing I did was creating an HTTP client, which basically means a file called http.ts, where I've exposed a bunch of functions like API sign up, API sign in, API create workflow, so on and so forth, so that I can just use these functions in various components rather than writing, Axios requests raw in multiple components that we're going to write. So a simple HTTP client, if you were using something like TRPC, or if you're using something like OpenAPI spec, or if you're using something like, protofiles and gRPC, in that case, this would have been auto-generated. In our case, we created a simple HTTP backend, and hence a lot of this was not auto-generated. This was vibe coded. I just gave the index.ts file that we've created, the backend, to the LLM, asked it to create a client for it. It created this client, it looks pretty clean. And I can now use all of these functions, and they all have return types, and use them throughout my components. That's the first thing that I did. Then I asked, again, the AI to quickly write some very basic functional pages. That includes a landing page, fairly simple, an authentication page where the user can sign up and sign in, a dashboard page where the user can see all of their existing workflows, a create workflow page. This is the one that we created from scratch. And now this is a page rather than a component, where the user can come and create the workflow. A page where the user can inspect their existing workflows, basically see the graph. And then if the user wants to track their executions of a workflow, the last page for tracking that. That includes the front-end pages. We had to change a bunch in the database schema. This might have been obvious to a few of you, but if you remember, whenever you are creating a workflow, let me quickly show that page again. Whenever you're creating a workflow, every node can have fairly dynamic things that it expects. For example, a timer expects a time. A price trigger expects a price and an asset. A lighter node, like this one, expects the type, the asset, the quantity, and the API key. API key being the credential, and these three being, the part of the metadata. Earlier, we had a very big if check. If it is a trading node, then show these three types. But now, since we can have various types of nodes, the schema of the nodes table has changed, and along with the credentials type, which was the various credentials we expect from the user, there's another field called metadata schema. For every node that we create, we'll write the schema of the metadata that the user needs to provide us. So every field over here, as you can see, there are 3 fields here, represents these 3 input boxes or inputs that the user needs to provide. The schema of which looks something like this. Is it a select? For example, this type is a select, which can be either a long or a short. And that's exactly what's mentioned over here. It is a select. The title is type. This is its description. And this is the types that it can be converted to. It can either be a long or a short. Similarly, another select for the asset. Right now we support 3 assets. That's Sol, BTC, and ETH. And then lastly, quantity, which is how much Sol, BTC the user wants to buy or sell, or long or short. Every time we create future nodes now, all we have to do is for that specific node in the database, provide the metadata schema along with the credential schema. This is slightly different from how N8N does it. If you ever look at N8N's code base, whenever the person adds a new node, they write all of this in the final TypeScript file. They create a TypeScript file for their node, and this schema is mentioned over there. I personally think that might be a better approach. One good reason for this is, since we have added this type in the database, we somehow have to extract this type on the front end and the back end for type safety. Versus if we had this not in the database but in the code, things would have been easier. Also, if a user wants to contribute a new node, if all of this was part of the code, they can just create a patch file on GitHub. Versus if it is part of the database, it becomes a little tricky as to how we let other users, if this is an open source project, how do we let other users create nodes? Which is why I don't love this approach of storing the schema in the database. Ideally, I would have wanted to keep this somewhere in the backend code, the front end code, or maybe a new package called nodes where we put it, so that whenever new users come and want to contribute nodes, it's easier for them. Without getting access to our database, they can create new nodes. Now they would need access to our database to do this. So that's another big change that was made. Without this big change, we had a bunch of hard-coded things on the front end, which wouldn't work if you have more and more nodes that are added. What else did we change? Unfurling these dynamic fields on the front end. So I've written the logic, or more technically, AI wrote all of this logic. But like fairly simple logic. Okay, whenever the credentials type is an array of a bunch of fields, or metadata schema is an array of a bunch of fields, they unfurl on the front end so that the user can provide us this data and create a specific action. And that's it. When you click on publish now, it publishes, and it crashed for me. Could have sworn it was working a second before. So let me see what's up. Cannot read property of undefined. Is the backend dead? Let me quickly debug this. I think what went wrong is I didn't really add any metadata for the lighter node. So let me quickly do that. This time, let me add a long on a Sol with this quantity and this API key and click on create action. Now, if I publish it, I see the graph. And if I go back to my dashboard, I can open this workflow and see the graph, what I created. I still don't have edit functionality, which should be easy enough to add. And there's a button that takes me to the executions. Right now, there are no executions happening for this specific node. And that's the next step. How do you write the executors? How does every 123 seconds this long on this lighter platform happen? That needs to basically involve us creating if you remember the architecture, that involves us creating the trigger poller and the executor. So to keep things simple, we can actually just have the executor for now. Let's do that. Let's only have the executor where, in our case, we'll execute all the workflows on, whatever the specific time stamp is. And this needs to right now talk to lighter, but eventually as you have more nodes, it'll talk to other nodes as well, or, other services as well. So right now we have a front end, back end MongoDB. The next step is writing the executor. The thing that the executor needs to do is go over all the workflows and find which one of these need to execute now. The ones that do need to execute based on, if their time has been reached, or if it's been 1 to 23 seconds since, this trigger was not, this workflow was not triggered, it needs to re-trigger it. So based on this time, this executor needs to place a trade on lighter given the user's credentials, because when the user created this, they also provided us with their API key. That API key is enough for us to place a trade on lighter. And eventually when we have more nodes, we'll have to have more custom logic for each and every node. That basically means whenever the user introduces a new node, they have to make a bunch of changes. Number one, they have to change the database and add the schema of the thing. In the front end code, they have to update this nodes folder and add their, if it's a trigger, then add some logic over here to show the trigger, the component, basically how should the thing visually show up. Then similarly, if there's an action, create a front end or card for that specific component and how it should look. And then lastly, they also need to write some logic in the executor, which is what we're going to write next. Next up, we're going to create a new folder called executor, which is right now going to do only one thing or support only one kind of a trigger. As we add more triggers, the executor becomes tricky. I think primarily the job of whoever is creating this or creating something like N8N needs to be make it very easy for admins to add more nodes. In our case, it's not super simple right now to introduce more nodes, but ideally whoever is creating it, their job needs to be to make it super simple to add more and more nodes or support more and more nodes. All right, is there anything else we need to go through? If you want, we can go through one of these components, which is a good one. Create workflow is a good one. Dashboard is a simple one. Seems like there's some change here I did not add. So let me add that. If you look at the dashboard, it gets all the workflows. Again, it gets it through a use effect, which is not great. I'm sure there's a hook that we can expose over here. A hook like use executions or use workflows, which makes this a little cleaner. But for now, an effect runs that gets all the workflows and sets them to the state variable, and then we just render all the workflows in a for loop somewhere here. There you go. We iterate over all the workflows and we create a simple card for them that looks something like this. On the front end, it looks something like this. All of these cards are actually rendered through this for loop. If you've done React, I'm hoping it's straightforward to understand, which is we render the workflow space, the ID of the workflow, that's what you see over here. And then, how many nodes does it have? How many edges does it have? And then two buttons that take you to the executions page or the workflow page. If you try to inspect the code of this workflow page, it's as you would expect, which is, again, I haven't written this. This was primarily I told, AI to write it and it did. This looks pretty simple. It gets the workflow, stores it in a state variable, and then simply passes the nodes and the edges over here. If we want to make this editable, is where things will get interesting. If we want to allow the user to, whenever they come on this page, they're able to edit this workflow. Then we need to bring in some of the logic of the create workflow component over here. We already have a backend endpoint for it. Front end might not be too difficult. I think it should be straightforward how to make this. We can add a button over here called edit, and when the user clicks on it, let the user edit this workflow as well. And so on and so forth. I think other pages are pretty simple. This create workflow page is the one that we created initially in the first 2 hours of the video. With that, we'll move on to the executor. The last thing over here, I've created a folder for it. Let's understand, what does the executor need to do? If we're only supporting 2 types of nodes right now, a timer and a lighter node. And eventually, if we add more nodes, then the logic will become more and more complex. Let's get into that next. Right, let's start to write the executor next. I'm going to go to the newly created app called executor, do a one init. And here we have to write the logic that pretty much constantly runs, gets all the nodes and checks if there is a specific trigger that needs to trigger now. So should start off with an infinite for loop or a while loop. Let me write a main function that's async and call it. Inside which what we'll do is we'll first grab all the nodes that exist. That means DB needs to be a dependency here. We do a global one install import. What do we import from DB? Probably which model? The workflow model, I think. Yeah. And we'll fetch all the workflows. So workflow model dot find all the workflows. And for each workflow, are supposed to do a few things. Since we only, I mean, there'll be a very big switch statement here, or a bunch of try catches, not try catches, sorry, a bunch of if else's. Let me start off with a switch case. Depending on the type of the workflow trigger, so const trigger equal to workflow dot nodes dot find x dot. Let's see, how do you find if something is a trigger? The node is going to have dot data dot kind set to trigger. And this is where the switch statement comes up. So if trigger dot data dot metadata dot not metadata, let's see, if trigger dot type equal to or switch trigger dot type, if not trigger continue, or return in this case. But if there is a trigger, and if the trigger dot type, what's wrong here? I don't know. How do you write a switch statement? There we go. Case, what was our very first node called? Let's see. The trigger was called, probably title is, no, not the title. Type. If trigger dot type is timer. How do you write switch statements? I think this is it. Yeah. If it is timer, then we want to check, has an execution happened in the last, X seconds for this specific node. So const execution equal to, so if there's an execution that has happened in the last, X seconds, whatever the timer is. So const timer equal to, time in seconds equal to dot metadata dot time. So trigger dot metadata dot time. If there is an execution that has happened in the last X seconds, so what we can do is const execution equal to, let's get the latest execution for this specific workflow. So execution model dot find one, where where the workflow ID is the same as the ID of the specific workflow. So workflow dot ID, and we need to sort it somehow, which is where we need to figure out how do you sorting in Mongoose. Dot find dot sort by the execution time, which I'm hoping we're storing somewhere. So db/index.ts. For every execution, are we storing the time? We have a start time. One probably means ascending. So it'll be either 1 or -1, I would assume. Let's start with 1 first. If execution dot start time is less than equal to if not execution, then again return. But if not execution, that probably means we need to immediately fire off an execution. So what we're going to do is start to execute this workflow, which will get tricky. So let me define another function or a file called execute.ts, which will export a function called execute, which takes a workflow as an input, whose type will probably be a workflow type that we have somewhere. We'll define this later on. Then execute. Or if execution.data.startTime start time is less than equal to, or is less than equal to of date.now minus greater than equal to, again there'll be some math here, the duration, which is basically trigger dot time in second. This variable, if the current time minus this thing के बाद वो आती है या के पहले वो आती है, then we're good. So it's less than equal to, or let's just do less than. If the start time is less than the current time minus times in second, that means current time में से time in second निकाल दो, उससे पहले this started. So I think that is good. In that case also we need to execute, else we can just skip it. That's it. The question really is, how do you execute the workflow, which will be a very complicated graph and a bunch of steps in there. So let's pass the workflow in here, which has all the nodes, or let's just pass the nodes and edges. Workflow dot nodes, comma workflow dot edges. So what comes as inputs here is the nodes and the edges that need to be executed. This will be, again, there should be a very comprehensive type that we have probably already defined somewhere. Or we can just check the type of, first of all, what's up here? To number or something like that. Dot get. I think that should be the right number. We'll confirm with a few logging statements eventually. The bigger question is, first of all, this await does nothing because execute is not an async function. Let's make it an async function. Let's check the types of nodes and edges here. It looks something like this, which is something we've probably defined somewhere already. I don't want to redo this type. I might have to for now. But I think this type should be defined somewhere else, and we can just, reuse the type here as well. Probably in that hook that I've written, which is use actions has a node document or an action item or a trigger item is what we're looking for. So use trigger. This type should probably be shared through, the common package that we have. If I paste this here, let's see. Don't need to worry about that. This is what a node document would look like. And edges are much simpler. Edges are type edge document equal to, there's a source, which is a string, and a target, which is a string. There's an ID that we don't care about. Edge document array and node document array. Great. We have the nodes and the edges over here. What we need to do is do a BFS, transfers to the graph, and execute the final thing. So let's write that logic first. Let's write the logic of going through the graph and executing it. We have the nodes and the edges. Oh God, this is like a lot of DSA logic that we have to write now. Where you have a bunch of nodes and edges, and we need to start from the very first node, which is the trigger, and start, it'll probably be a recursive function. So let me write that. Export async function execute recursive. which takes, the current source ID as an input, which is where we're starting off from, which will be a string. And then takes, again, the nodes and the edges as an input should be fine, I think. All right, we can just call execute recursive with the trigger ID. So that's going to be nodes. I think we've already written this here. X dot kind. Data dot kind. This is incorrect. The nodes type is going to look something like this. It'll have an ID. It'll have a type, a position, which we don't really care about. Let's just remove that. Credentials, which we do care about. Data, metadata, kind, and that's it. That's what a node document should look like. Is there something else in here? Let's see. Node ID is the only other thing which is also important. Yeah, it's also important. This is, what node this belongs to. Is it a lighter node or something else? That also means we will have to probably at some point use the node model or nodes model. All right, cool. So find data should exist वैसे तो nodes dot filter or find executor is probably null, or is it? Probably not. Trigger dot id. Now the question is, should it be trigger dot id or node id? ID. I can confirm this by going here and seeing what ID. Yeah, ID is fine. Trigger.id, comma, nodes and edges. If not trigger, return. This would never happen, but just to make TypeScript happy. All right, we have a source ID. Now we need to find everything that comes out of this source. That means all the edges from the source to a node. So const edges, or const nodes to execute equal to now I can make this fairly optimal. I'm writing a n square function here. We can make it an order n function. If you are a DSA fanatic, feel free to do it. It's going to be edges dot find. Actually, this will be order n. Source comma target source equal to source ID dot map target. So we get the ID of nodes to execute. Eventually, we need to call execute recursive on each one of these. So nodes to execute dot map wait new promise ID followed by execute recursive ID comma nodes comma edges. Beautiful. Most likely should be a string array, right? Dot find filter followed by find by map and await new promise dot all. Actually, it'll just be await promise dot all. My bad. There you go. That should do it. So what this is going to do is recursively call the same thing on all the, basically transfers through the graph. The only thing that's left is actually executing a specific node. So for every node to execute, for or map again and again await promise dot all node id source or node id is fine. We need to actually execute the node, so let's call it node id is fine, even though node id is probably not fine. Id is a better term for it. Node id can be the id of the node in the nodes table. So this id right here, what we're looking for is this id right here, the 0.17 id. That's what I'm calling id here. Now I need to execute it, which should be simple enough. Const node equal to nodes.find id. Let's call it node client id. Id equal to node client id. Once we find the node, firstly, if not node, then simply return. But if there is a node, then we need to find the node dot type. We need to find the node dot type, and if it is, for example, timer, no, it'll never be timer. It'll be an action for sure. So it'll be node dot type is lighter. So yeah, again a switch statement on node dot type, and if it is lighter is when we write all the logic for executing lighter. So let me create another folder called executors, and let me write another file here called lighter.ps, where I'm going to write the logic for executing a lighter node. So export function execute. This will take a lighter position as an input, so the asset that the user wants to buy, which in our case, if you remember, was Sol or BTC or US ETH, the quantity that the user wants to buy, which will be a number. And then lastly, the asset, the quantity, and I think that was it. That's all that we expect from the user, right? If you look at the data or type, which is a long or a short. There we go. And this is where we have to write the logic for placing the trade. The only other thing is we'll also take the user's metadata, which in this case was just the API key, which is a string. There we go. I'm going to pass all four of these here. So I'm going to call import execute as execute lighter from ./executors/lighter. And I'm going to call execute lighter here with the right inputs, which is going to be asset is going to be node dot data dot metadata dot node dot data dot metadata dot asset, comma, quantity is going to be dot quantity, comma, type is going to be dot type, and the API key is going to be node dot credentials dot API underscore key. So node dot credentials dot API underscore key, and that's it. Await that. This should have the actual logic of executing the trade. So I'm just log that. Should I log that? Let me just log that for now. Executing trade on lighter, and let me log everything else. So console.log asset, quantity, type, and API key. That should be good enough. Let's see if this works, and then I can add the business logic to actually execute the trade. That's the simpler part. Let's see if the executor is working as expected or not. The only thing I'm worried about, a few things I'm worried about. First is this, what's up here? I don't know, we'll figure this out. Something is up here with the type. But before that, I need to basically check if this timing is correct or not, the if else statements that we have. So let me just log a few things. Okay, this we will never know until the first execution happens. let me do one more thing. Let me put this execution after everything is done. Await execute is done. Hold on. Yeah, await execute is done. Is when we should actually put an entry in the executions table. So execution model dot create. And what does it expect? It expects us to give. Oh, we should probably create it above and update it later. So if either one of these happens, so this or if not execution or the condition that we have, either one of these things happens, we need to execute. And before we execute, let's do a execution model dot create with a workflow ID, a status which is pending, a start time which is date.now, and no end time. And then once it is done is when we execution dot end time equal to date.now, await execution dot save. There we go. I think that should update the execution times correctly. There's some problem here. Oh, execution number is not assignable to date. New date, and then probably this should be new date as well. All right. One thing I want to do is let's wait for one execution to happen. Let's just put did put a bunch of logs. So let's see. Let me delete all the workflows that I've created. So delete this one, delete this one, delete this one. How many do I have? Not many. So let me quickly delete them. I'll only have one workflow left by the end, which has a mildly complicated graph, nothing crazy, and test it out. So I've deleted everything but the last one, and last one has only one edge, I think, and two nodes. The first one being a timer to run every, to run every 123 seconds. Let's make this every 20 seconds. So every 20 seconds, it should run this thing, which is place a trade on lighter, which is going to be a long on sol with a quantity of 10. Let's see, does that happen or not? So monindex.ts in apps / executor. Let's see what that does. I see no logs until this point. One thing I probably need to do is do a mongoose.connect. This is a separate backend. So from mongoose and then mongoose.connect process.env.env mongo URL. I should probably await this, and then the thing should start. So let's do it now. And notice it's placing a bunch of sol longs one after the other. Is it making an entry in the executions table? It is, and there are too many of these. That means my logic is incorrect. The logic that the if else logic that checks has 1 to 3 seconds passed or not is incorrect. So let's log that next. There are too many entries that have happened, but that's fine. What we're going to do now is let's not do any of this. I just want to see what this logs to and what this logs to and what is time in seconds. Let's run it, and it's 46. The first one is probably, so it's basically the time that has passed since that time, I would assume. No, it's still 46. Yeah, still 46. Oh, it's just the seconds of that span. Never mind. It's like this seconds, 46. This is what 46 means. Probably also means we're getting the wrong one. So this should be -1. And let's try that. 48, which looks like the right one, getting the latest one, 47.77, which is equivalent to 48. The problem is, how do you get Unix timestamp for a date? Get Unix, I think that is correct. It's also 204. Get UTC hours. Get what's the type of start time? It's just a string. So what if I do this? New date dot get time. There we go. That looks perfect to me. So it should have been this. Let's try that now. Run index.ts. Oh, one thing I forgot is let me uncomment all of this. Run it. And oh boy, too many of these again. Maybe the logic is incorrect now. Relog everything. All right. Execution.start time is this number 4018. Current time is this thing 4018. Okay, that is incorrect. This should probably be 1. Let's see. This looks more closer, or does it? 402. Okay. I'm definitely doing something wrong with the sorting. Sort by timestamp date in Mongoose. Find sort submitted date -1. Dot find reviewed true dot submitted date descending. Descending sounds probably right. These look really far. Yeah, descending looks like the right thing. Let me also just log the date and not the whole thing. What I want to see is, do I get the last time or not here? So that's 004305. And in MongoDB, if I refresh and look at the executions, the latest one start time is 004047, 0043, 4047. I think this is my local time and this isn't. I actually could be wrong. Yeah, the only way to probably test this is look at the logs and see if, things are going bad. They still are going bad fairly quickly. All right, time to debug. This actually, I'm just logging the thing as such, right? Execution.start time 4526, and then a bunch of things. There are too many pages now. There you go, 4526. That's the one. That looks fine. It is getting the latest one. I think my logic is incorrect now. Is this milliseconds? Probably is. My bad. So it's going to be this in 2000. My bad. I think the logic was correct. Only thing is everything was in milliseconds and not seconds. If I run index.ts again, oh boy, why is it still executing it again? Console.log this thing followed by date.now followed by time in seconds minus 1000. Oh, sorry, into 1000. Only thing I can think of is baud mass, but I think it applies correctly. Console. Okay. Oh boy. The last thing looks fine, 20,000. Date.now looks fine. What went wrong here? Oh, seems like I forgot to change the thing here. What was it again? It was new date dot get time. All right. Yeah, I was just not, I logged the right thing. I never put it here. Let's try it again. Okay, it did place this and then no more orders. It placed it twice, which is a little, am I not awaiting? I am. Okay, that's fine. It happened once. We're going to wait for 20 seconds now. And hopefully after 20 seconds, the thing executes again. There we go. But it's doing it twice though, which I don't love. I'm sure there's an easy way to fix that, which is introduce a timeout, which we should anyways have had. Basically, after the while loop ends, wait for like 2 seconds, await new promise, timeout, x comma 2-second breather. All right, let's try that one more time. All right, hasn't been 20 seconds, but now one trade executed, beautiful. And after 20 seconds, hopefully another trade executes. I'm going to keep this live after I confirm this works. And then I'm going to create a more complicated graph and see if that works as well. 20 seconds, almost there. There we go. This seems to be working. The client is up. Let me start the backend as well. App/backend, one index.ts. And let me try to create a new workflow, which is a little more complicated. Every 10 seconds, we want first a lighter node to execute that creates a long on sol 10 quantity random API key. And then once this is done, I want to do two things. On lighter, I want to do a short on BTC of one random API key. And I also want basically to test if BFS is working or not. I want to do another short on BTC of one quantity and random API keys. This is what my graph looks like. Ignore the debug statement at the top. But first this long should run, then these two shorts should run. Let me publish that and let's see if that happens or not. If I go back to the executor, notice it did a long followed by a BTC short followed by another BTC short. That was it, right? One shot. Yeah, that looks good. And it's happening every 10 seconds. Every 10 seconds, it is executing a long on lighter and short, and long comes first and then the shorts come, which is great. Should I make it more complicated? I could, but if I look at the executions, all of them are pending. Oh, we need to update the status as well. This is where, yeah, it would have been super helpful. Execution dot status equal to success, which is something I missed. Let me try it again. And now if I refresh, wait for one more execution to happen, it did happen. And it shows success over here, which is exactly what I wanted to see. So this is the workflow. This is its executions. We can add more logs over here so the user can expand it. One thing that is left is actually placing the order on lighter. So let's do that next. I have a lighter SDK written in TypeScript, which should make it very easy for me to place a long or a short order for BTC ETH Sol. So this open function that we have, where I'm just logging things right now, which was this right here. Let me actually implement the lighter logic. Given a user's API key and their intent, what do they want to buy and how much of it do they want to buy? Let's actually place that order on lighter and then let's see it in action. Moving on to that next executor, writing the very first executor, which is going to be the lighter executor. All right, I've quickly implemented the execute lighter function. Things have changed a bit. The arguments that you need, basically a good starting point for this is just go through the lighter SDK on GitHub and try to go through the examples. So let me quickly take you through the example that will show you how to create a position on lighter, which is this create order, create position, I think is the right one. This is it though. No, this isn't it. Create order is probably the right one. If you look at this example, you create basically a client, think of it like an HTTP client to the lighter, backend servers, and then you call this create order function. Notice the inputs that it expects is one, a private key, two, an account index, and three, an API key index. There are three things that are required. And if you have an account on Lighter, which is basically a place where you can place trades, you can generate all three of these. Your account index, your API key index, and the private key. The way to do all three of these is you sign up on Lighter, put some funds in it. For example, I have, if you look at my portfolio, I have $774 in it. Using these $774, I can place trades. So what I'm going to do is I'm going to click on tools and select API keys. Here I can create an API key. This is the API key index. This is the actual public key. There's a private key of the API that I've stored. And last, there's an account index, which is my current account's ID, which you can get by, inspecting the network request. So if you click on right click, inspect, network tab, refresh, somewhere you'll find, your account index. Let me see if I can find one really quickly. There you go. This is the account index, or index of my account. You need all three of these, basically an account ID, an API key index. It went away now, but an API key index that was present over here, two, and then the actual API key. Whenever you generate the API key, this private key will be available to you using these three inputs. And hence, if you look at the nodes now, they have changed as well. The lighter node, I've changed the database schema to accept not just the API key, but an account index and an API key index as well. You need all three of these inputs to place a trade on lighter. And it was very easy for me. All I had to do was go to MongoDB, select the specific node, which was this second node right here. And in the credential schema, I also added account index and API key index. I added two more fields. They now unfurl over here on the UI. And using this, I created this workflow where I've put in the right credentials to my account. I don't want to share it, which is why I'm not adding it in front of you. But this specific node, when I created, where I want to long sol every 60 seconds with this quantity, this specific node was created with the right lighter credentials. Hopefully, I haven't tested it right now. So we'll see if it works or not. I am going to now, I've created the node. So as soon as I run the executor, if the logic that I've written is right, which if you look at it, it basically takes all of these inputs, the asset, the quantity, the type, the API key, the account index, and the API key index. These three are the credentials. These three are the standard metadata for this specific request. What I do is I try to get the market ID on lighter for this specific asset. So for BTC, it's 1. For ETH, it is 0. For SOL, it is 2. And the quantity decimals, which basically is, what should you multiply the quantity by. If the user wanted to buy 0.01 SOL, then the request that we sent is going to be 0.01 into this specific number. It's just, a multiplier that is expected whenever you're sending a request to lighter. For SOL, that's 1,000. So in this line of code, this market ID and this quantity decimal will be extracted. We create a new signer client, or a client to lighter, and we check, is it an ask or a bid? And in case the user is trying to short, that means you're asking for a specific price. If they're trying to long, then you're bidding. Okay, I'm willing to bid at the specific price, which is why is ask variable is going to be false if it is a long, and true if it is a short. And then we just call this specific function, which again, if you want to dive deeper into Lighter's specific SDK, you should go through my last video where I've sort of built an AI trading bot using it. Or just go through the examples in the docs. But either way, this function call will actually, hopefully, place an order on the exchange. So let's see, does that happen or not? If I run, actually, this seems a little wrong. Client order index should just be a random variable. So, something like math.random into 10⁻⁶, math.floor. Yeah, I don't think you can repeat this. So this is just a random number now. All right, let's try it now. Let's run the executor, and hopefully I only have one workflow now. I've deleted all the other workflows, and hopefully this specific workflow runs. Let me put a log here. Console.log executing trade, and the asset, the quantity, and the type. Let's see if that happens or not. I need to go to executors, lighter SDK, and do a one install. That should do it. One index.ts, and now executing trade throws an error. Return from no transaction data return from signer. Oh boy, that probably means the inputs that I'm sending are incorrect. So this is a market order. I do remember this used to create some issues. Let me quickly try to debug this. I know I've debugged this once here. Let me see how I was creating a position here. Market index. I think price might be required, but the good thing is you need the latest price for that. This is going to get really tricky. Yeah, I mean, what we can do is what I've done here as well, which is we first get the latest price by using something called the candlestick API, which we can get from the lighter SDK client that I've just added. And once we get the latest price, I can also provide a price at which I'm willing to buy or sell. Actually, it might have just worked without this. Let's try that. Oh no, this does throw a type error. This is going to be if type equal to long, I think. Yep. Then latest price in 2.1, otherwise this into this would be basically the price decimals. Oh boy. So we also need the price decimals, which comes from, we can find it here really quickly. Markets.ts probably has the price decimals as well. I'll share what these price decimals are in a second. Let me quickly add them. So price decimals represents whenever. So what we're doing now is when we create an order, we also give it the price at which we want it to be executed, which is the current price plus a small amount, or the current price minus a small amount. If you're trying to long, then we say, okay, I'm willing to long at this price or a little bit more expensive. If you're trying to short or sell, we say I'm willing to sell at this price or a little bit less as well, and hence 0.99. The current price though is fetched from this API, the candlestick API, and when you're telling it the price, you don't give it 160. Let's say the current price of Solana is 160. You don't give it 160. You give it 160 into the price decimals, which in this case is 1,000. So over here, we need to multiply this by price decimals, which is going to be markets of asset dot price decimals. And that should hopefully actually place an order. So let's try that again. There should be an easier way to do this. This also failed, by the way. But this time, I think, let me just log what the latest price was. Oh, seems like the workflow is already executed and hence it isn't executing it anymore. So let me delete that. Let's try that again. Oh shoot, I deleted the workflow. I'm such an idiot. Command Z. God damn it. I deleted the workflow. I was supposed to delete the execution. Time to debug. Alright, a surprising thing fixed it. When I changed this from a market order to a limit order, seems like the transaction signing is happening. Unfortunately, a lot of this is a black box because of how the SDK is written, which is I'm not diving deeper into this. I still should debug why a market order isn't working over here. If I try it now, I think that should have executed the workflow. If I go back to my lighter, you can see a 0.01 sol position has been opened. And if we wait for 10 seconds, now the position became 0.02. If we wait for another 10 seconds, the position becomes 0.03. And if I go to this execution that I had now recreated because I deleted it in the last section, if I look at the executions, I see a bunch of pendings, which should ideally be failures because when I was debugging, they were all failing. And the rest are successes. All of these successes, if I have 5 successes here, that means I have 0.5 sol of a position open on lighter. So hopefully that was easy enough to digest. Let's try something more complicated. This workflow is running, seems to be working fine. There's no edit functionality, which would have been nice. Unfortunately, we don't really support a lot of, triggers right now. The only thing that we support is a timer trigger, and the only action that we support is a lighter exchange right now. Sending out an email might be a good one, which also should be a very easy one to add, by the way. That can be a good assignment. Like after I push this to GitHub, I'll probably create an issue that you can pick. The simpler one would be sending out an email, adding other exchanges over here, so on and so forth. But yeah, since we just have this much, it wouldn't really change much. Let me do a ETH long 0.1 every, 22 seconds. I'll have to put these, which I can't show you on screen. So let me quickly hide myself and create this second workflow. And let me create another one. You guys can't see it right now, but another long for, let's say, BTC, again 0. BTC should be even smaller, right? 0.1 ETH also is a very big number, actually, $400. I guess that's good enough. So I've unfortunately created a very hefty position here. That's like $400 worth of a position every 22 seconds. I don't have enough money to sustain this for, even a few minutes. So what I'll do is I will go back to lighter and close. Oh yeah, I created it. It's automatically already happening. The sol positions and the ETH positions are opening up. The ETH position, only 0.1 ETH is open right now. But in a few seconds, you'll see this go up to 0.2. Let me close the sol positions. As you can see, every few seconds, the positions are stacking up. And that is because we have 2 workflows now. The one that I just created. And if you look at the executions, it has executed twice. And it is executing every 22 seconds. So every 22 seconds, it is creating a position on lighter. And even the amount of ETH that I hold is going up. The same is true for Solana every 22 seconds. Great. Let me close these positions. Not that it would matter because we will just reopen them in a second over here. But yeah, that's a high level of how you would build an automation sort of a platform end to end. The challenging things, if you've seen the video throughout, were creating the node schema graphs. Executing them was also pretty interesting. Writing this recursive function, I did BFS after a long time. It did require a little bit of, DSN knowledge. Probably can be optimized a little further. I'll probably run a full vibe code, fix the UI, make it prettier once, and convert it to dark mode, something like that. And let's see, what AI can do with a fairly rudimentary UI right now. And I'll push this to GitHub, share a link in the description, and add some issues if you want to build on top of this. I think there's a bunch of things that can be fixed over here. This is the best effort that I could put in like 4.5 hours. But the same project was done by a lot of smart folks at Super 30, which was much more professional. It looked UI-wise looked very close to N8N. Implementation-wise, when you open the graph, you could actually see the executions. And if this specific workflow runs, you could see a running trigger over here and a checkbox trigger over here, things like these. So there's a lot to do to build on top of this in case you want to. If you want to build it from scratch, hopefully this gives you a starting point. I would still consider this to be a fairly rudimentary, starting point of building N8N. It's a fairly complex application and there are various approaches you can take to build it. This can be one, but I personally myself, if I was building it for the long run, would take a few decisions differently if I'm building something very niche and complex like N8N. With that, hopefully the video was insightful. and hopefully you learned something new from it. Let me know what you'd like to see next on the next project video. With that, we'll end it. I'll see you guys in the next one. Bye bye. This is my childhood home, by the way. This is where I did a lot of J prep. Productivity max.